noise. पूरा का पूरा नहीं आया, मैं तो बोला ऑब्वियस का लोगो आ जाएगा, ऑब्वियस का लोगो आ जाएगा, स्ट्रीमिंग करना होगा, स्ट्रीमिंग करना है तो ऑब्वियस का लोगो आ जाएगा। तो क्या उसका सॉल्यूशन नहीं है? तुम्हें लगाना पड़ेगा कैमरा, तो मेरा कंट्रोल कैमरा को बंद करना पड़ेगा। हाँ तो कैमरा को पूरा बंद कर दो, देखिए क्या आएगा। कैमरा चालू रहने से तो ऑब्वियसली कैमरा आ जाएगा, तो मेरा फेस आएगा, थोड़ा मैं चेक करके जाएगा। कैमरा बंद कर देने से वो ऑब्वियसली लोगो आएगा, स्ट्रीमिंग चल रहा है। क्या फायदा है? कुछ फायदा नहीं है। इसे तो एक चीज है, वेस्ट वाला ठीक है, वैसे भी कौन देखेगा, तभी तो कुछ नीचे चीज चलेगा, तो कुछ चीज स्टार्ट होगा सर, कुछ समझ चलेगा। हाँ फिर तो लाइक के लिए कुछ नहीं किया, फिर ये किसी ने आ मैं भी ट्राई करता हूँ, तक मैं जो मैडिसिन कर दे रहा हूँ, मीटिंग में होता है, मीटिंग को कवर नहीं करता, ये मेरी मीटिंग रमेश तुमने सेटल किया है, वो आपको समझे तो मानो उसी हिसाब से सिग्नल ऑफ मेरे मेरे काम पे दो जाऊंगा, दो जाऊंगा, हमने आपने आपके साथ यहाँ पे नहीं बात की यहाँ क्यों जाएंगे, यहाँ बैठ के नहीं कीजिएगा, सिस्टम आपका हो गया, सिस्टम आपका है तो बात करनी है, इसको कनेक्ट कर दीजिए, इयरफोन से तो कोई मैं तो नहीं होगा। आप यहाँ तो अपना वीडियो ऑन करके आज शूट अप नहीं आएगा तो अपना वीडियो ऑन करके तो नहीं आएगा, तो यहाँ से इधर नहीं वो जो कनेक्शन है वो मालूम है, तुमसे ज्यादा इन लोगों का पता है, कनेक्शन में जाना हो दो तुम कितने जानो नहीं कहते কি তা এটা কোন এটা কোড আছে এটা তো এটা না আসেনি ও এইটু কোন একটা কানেকশন ହେଇଛି ବୋଧେ କ୍ରସ୍ କନେକ୍ସନ ହେଇଯାଇଛି କ୍ରସ୍ କନେକ୍ସନ ଥାଉ ସବୁଟା ଅନ୍ କର ନାଇଁ ତା ହଁ ଲାଇଟ୍ ସେଟା ଠିକ ଅଛି ଲାଇଟ୍ ଦରକାର लाइट बता रहा ये कौन करके रास्ता के अजीब अजीब कैसे ब्लर दूसरा कौन है करके आसु आसु भी ये तो एक में जॉइन कर दे कौन सब लगे ना तो हां जॉइन कर दे हां इसके मल्टीपल लगेगा तो 8 मिनट ऑफ करना तुम्हें ऐसे समझना है।
ବାହାର କଲାରୁ ପାଟି ନ କରିବେ ହେଲା।
हेलो हेलो
सर नमस्ते।
सर नमस्ते, थैंक यू सर।
हेलो बेस्ट विशेष सर।
सर सर आवाज ठीक ठाक आसछि तो?
हाँ ठीक अच्छी सर।
नमस्ते नमस्ते, थैंक यू सर।
ସାର୍ ଆବାଜ ଆସୁନି।
ଖାଇଲେ ଖାଇବ କି ଅଲଗା କୋଉ ଚଢେଇ ଖାଇବ।
श्रीनिवास गुड मॉर्निंग।
सर गुड मॉर्निंग सर, नमस्कार।
नमस्कार नमस्कार गुड मॉर्निंग। सब ठीक ठाक
सर ठीक ठाक चलছে सर। वॉइस केमता सर?
वॉइस आसी गोटे टिके बैकग्राउंड रे साउंड होची सु सु करिकी बट ठीक।
सर बोधे भाबुची एसी साउंड ता बोधे सर आसी माने सेंट्रल एसी तो।
ओ हां 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 सेटा ही
सर
बढ़िया बढ़िया ହେଲା ଭଲ ଦେଖା ହଉଛି ଠିକ ଠାକ
हेलो सर
କିଏ ହ୍ୟାଲୋ କହିଲେ ମୁଁ ଜାଣି ପାରିଲିନି
बोधे सर काली सारंकर साउंड सुबुची
ହଁ କିଏ ଜଣେ ହ୍ୟାଲୋ କହିଲେ ମୁଁ ଜାଣି ପାରିଲିନି ଗୁଡ୍ ମର୍ଣ୍ଣିଂ ନମସ୍କାର ଓ ହେଇଗଲେଣି ଗୁଡାଏ ଲୋକ ଓହୋ Srinivas, you please check that it's not being recorded, not yet live, right? नहीं ଏବେ नहीं ଏବେ नहीं ପରେ କରିବୁ ନାଇଁ 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 ହଁ don't record now, we are discussing something else here. You check that Srinivas, you check that souvenir.
सर ये सर 1 second sir after start the meeting
हाँ
then 11 o'clock I will check the meeting.
yeah very good. What is the agenda for this? We'll just say ki, this is
Sir, inaugurated by you and I introduced the uh, your speakers introductions
yeah
and you
good.
will start this
Good.
first half tutorial by this Bibhudotta
Prasad
sir.
Patnaik also might join.
I have not seen sir.
Might join. I don't know. ତାଙ୍କୁ ପ୍ରୋଗ୍ରାମ ଟା ପଠେଇ ଦେଇଛନ୍ତି ପୁରାପୁରି
हाँ सर पठे दीजिए
ହଁ good then he will take his time and join.
सर सर
ସାର୍ ନମସ୍ତେ
ନମସ୍କାର କାଳି ନମସ୍କାର
ଭଲ ଅଛନ୍ତି ସାର୍
ହଁ ହଁ ଭଲ ଅଛି
sir I want to leave for 1 minute sir
yeah
to call Udgata sir sorry Bibhudotta sir.
yeah please call him Srinivas will start the process. अब कैमरा बंद कर दिया क्या? ऑटो बंद कर दिया क्या कैमरा?
Sir, Bibu sir will join shortly, sir.
Srinivas, I have joined. Hello.
Sir, welcome, sir. Bibu sir.
Bibu, good morning.
Good morning, sir.
Good morning, namaskar. Hope you are doing well. Yeah. So we'll start the process. Srinivas will start. It's already late.
Sir.
So how are you doing?
Fine, sir. Take time.
Good morning to all. Respected Professor Sivakumar Udgata and Professor Bivudata Sao and all delegates present over here. So thanks to all members and chairs to present over here and to carry out the process. Now, on behalf of the organizing committee, I request Professor Udgata to address something regarding the programs of these today programs. Sir.
Yeah, thank you, Professor Srinivas, and good morning, all of you. I'm pleased to be here. I mean, it's a pleasant morning, pleasant winter, mid-December morning, and I hope everybody is safe and they are taking good care of themselves and their family. Yeah. So I must thank the organizing committee and Professor Srinivas Sethi for inviting me to this conference and to this inaugural of the tutorial session. I think I'm also kind of indebted to Professor Bibhudatta Sahu of NIT Rourkela and my colleague Professor Nagendra Kumar Suryadevara from University of Hyderabad for agreeing to give 2 tutorial talks, pre-conference tutorial talks for this conference actually. And as you all know that this conference is focused on machine learning, Internet of Things, cloud computing, fog computing, and big data. So we got several papers actually, several very good papers in this domain. And we thought that for the interest of the participants, for the interest of the students, we should conduct a pre-conference tutorial so that people understand and we can give a brief overview of what is happening in machine learning, what is happening in Internet of Things, what is happening in fog computing, so that it becomes little easier for the early stage researchers to find some meaningful in those papers actually, because papers are very concise, presentations are very limited. So we want to give a brief introduction about the subject, and on behalf of the technical committee, we are thankful to Professor Sahu and Professor Nagendra Kumar for agreeing to give a talk here. Now I understand that there are more than 600 to 700 participants in the tutorial talk, and Google Meet has its own limitations. Actually, it doesn't allow more than 100 students. So I also understand that the organizers have arranged a live streaming in the YouTube with a, I mean, slight delay of around 15 to 20 seconds. It doesn't matter much. So most of you who cannot join Google Meet, or to accommodate somebody else, please look at the live streaming of the YouTube. And I'm pretty sure that both these sessions, I know them personally. I know Professor Sahu for decades. I know Nagendra Kumar, who is my colleague here. Both of them are excellent speakers, having not only speakers, they have the depth in that particular domain. And I hope all of you will enjoy, and particularly the early stage researchers will definitely enjoy it. And I'm looking forward to these 3-day events actually. And for people who are attendees who are authors, I must congratulate them that they have pulled out, and we have got very good sessions lined up. Particularly in this conference, I must say that we have some, I mean, excellent keynote talks focused on applications, focused on industrial applications, focused on what is going on today. So we have speakers, keynote speakers from senior most professors in the country like Professor Alam Patnaik. We have people from professors, young professors from South Africa. We have industry leaders. Dr. Tinku Acharya is an industry leader. We have Dr. Subramaniam Swami. He is also an industry leader, and they have developed a kind of an excellent applications for COVID-19 detection using eye scan and all that. So he will be presenting tomorrow. So I expect and request all of you to be present, listen to the keynote talks, and I, on my personal behalf, give you guarantee that you will actually enjoy the program actually. So with this small talk, I welcome all of you. I thank Professor Sahu, and I'm looking forward to this excellent presentations actually. Thank you, Dr. Srinivas.
Thank you, sir. Thank you, sir. So, on behalf of the organizing committee, sir, may I start the process for the first half of this program?
Please introduce Professor Sahu, and
Yes,
then
sir.
you can start it.
Yes, sir. So, on behalf of the organizing committee, the process will be start for the program, first half of the tutorial programs by the Professor Bibudatta Sahu, is an associate professor of the Department of Computer Science and Engineering at NIT Raurkela. Has been conducted with the different different projects throughout the career. Actually, he started the career from this IJD Sarang in this institute. In the year 2000, he joined NIT Raurkela, and he got a lot of awards, like you are from these and young scientists and good teachers, okay, different awards, and have the different project during his professional life. And he also member of this live member of the CSC, IET and IST, and your ISCA and Odisha Science Academy also. He is the member of this IEEE professional ACM members, and have the different book chapter research to around 250 publications, including the book chapter, journals, essay journals, Scopus journals, all kind of the journals. So it is the very last time to introduce the Professor Bibudatta Sahu sir to shortly introduce. So may I request Professor Bibu sir to start this tutorial, sir. Sir.
Thank you, Srinivas. Thank you, Professor Udgata. So it's a pleasure to be with you on this tutorial. So I'm sharing my screen. Please confirm
Yes, sir.
it's available to you. Then we'll be going for the presentation. Srinivas, can you confirm?
Okay, sir.
Yeah, the screen
Okay,
is
sir.
visible. full screen. You can make it full screen. And,
Yes, yes, sir. I'm going on with that. Just I need to close few presentations and
yes.
now it's okay.
Okay, sir. Need full screen, sir.
Make it full screen.
Now I have made it full screen on my side.
So what you have to do is that you have to
Okay,
share
I'm
that
starting the
window.
entire.
You have to share that full screen window, not this window.
Okay.
In actually
No,
Google Meet, what happens is the full screen window is different and the PowerPoint window is different.
No, I'm going for the full screen, entire screen.
Yes, that's better.
I'll go for the entire screen.
Yeah, that's better.
Is it okay now?
Yeah, perfect.
Yeah, sir. Okay, sir.
Perfect.
Okay. So, welcome all the participants. Thank you to the organizer. And here we are going to start a tutorial. As you know, in a tutorial, we start from the very basics. In my discussion, I am not going to address a research issue in depth, rather than I'll try to cover some basic issues. Basic issues, I mean, being from the computer science, we try to relate some current technology with different fundamental things like operating system, architecture, maybe database, maybe security, so that you can get a clear picture and you can appreciate what you learn in your basic studies and how it is related to the current technology. So this topic which I am going to address, in general, I am talking about first the fog computing environment, or you can say it can be generalized as the resource management in fog computing. So when I say resource management, what are the resources in fog computing? Maybe you can try to relate something, your concept of the operating system, how different resources are managed with help of the operating system as a resource manager. That is the reason I say I am taking reference of your basic computer science papers or the terminology so that you can get a clear picture. Then why we go for a fog computing environment, and I think it's a very much fundamental that if you want a IoT application, so what exactly IoT application is and what is the basic characteristic of a IoT application. And sometimes you'll be finding some terms are coming. I try to clarify that a real time or a particular word when we try to define IoT application. Okay, so we'll start with the introducing the technology of the fog computing environment. Then we'll slowly move towards the different open research problems address, what should be the approach to carry out the research. So now, the first things to be clarified, there are two terms like fog computing and the edge computing. People are confused sometimes with that. You see, these fog computing is credit or the patented goes to the Cisco, started with 2014. And then in 2015, IBM come with a similar type of concept, which they name it as the edge computing. That is because of the patent and other issues. So in fog computing, if you want to learn on the fog computing and the research development, how the hardware and how the other things has to be integrated, most of the things are the solutions, or you can say the resources are coming from the Cisco. So if you want to concentrate on the basic fundamentals, details related to even devices, my suggestion will be to refer to the white paper available with the Cisco site. Okay, so the term fog computing is coined by Cisco. Now we are coming into a particular world called fog layer. Then it says a fog nodes, which is essentially an industrial controller, gateway, computer, switches, IO devices. Okay, so now these devices, how they operate, how the controller has to be placed there, what are the technology available so that we try to deploy a specific application on the top of either on the top of a gateway or on top of a switch or on top of a IoT device or on top of your smartphone or a computer, or maybe if you're looking into maybe to a roadside unit, if you'll consider a vehicular network like this, or maybe to your mobile towers where we can have the different nodes. So we'll clarify all those things. So basic idea of the fog computing is that it's a layer introduced between the user layer and the cloud layer. So when I require a computing infrastructure or computing resource, I can have my own, or I try to take a computing resource which can be accessible through the internet, and that is going to cater my computational need. So that leads to the resource pool like a cloud computing. I need a computation, so I don't have any computing power. I try to upload the task to a virtual computer or a computer available through the internet. So that is roughly I'm talking of the concept of the cloud computing. But what happens when we look into different IoT applications? These IoT applications are latency sensitive applications. When the latency sensitive applications are to be executed and a decision has to be delivered, and that decision has to be reflected again. The decision has to be reflected again, and that has to be done within a time frame or within a time constant. Then we are looking into a particular application with a deadline. Okay, sometimes we define a real-time application, then we categorize the real-time application as a hard deadline, soft deadline, and firm deadline. Mostly we are talking of IoT applications which are with the soft deadline. Little bit about real-time system and knowledge is required. So latency sensitive real-time application with soft deadline is the particular application which we are talking about. And for that, we need an infrastructure so that we can get the action. We can get the action to be executed at our end. Because whenever we try to do an application or an IoT device has been used, we talk of, okay, some decision has been taken. Simultaneously, we are also accountable how the decision will be implemented. Again, the feedback again sent back to the device maybe for the next step of action. Okay, so it is, so if you look into the third point, is intended to bring the computational capability of the system close to the host machine. Okay, so a fog layer is introduced. So if roughly if we look into that, these fog layers are dedicatedly designed only for IoT applications. That we are bringing whatever the capability or facility available with the cloud computing is close to the user so that latency will be minimal. Okay. So then in 2015, IBM, they are also the leaders coming with their own concept, and that is the edge computing. Sometimes people use those words interchangeably. So we have to take a little bit of precaution. Maybe the last layer device, you call them as the edge device. But when you are defining fog layer or edge layer, one has to be careful. And sometimes a few researchers, they combine and they write fog edge or something like that. But everything depends on which system model you approach or which system model you refer. Okay, so in a nutshell, the cloud the fog computing is nothing but a standard model of the cloud computing, so that the computing resources are very close to the user. So roughly, we are discussing a 3-layer model, but this is not the ultimate. Remember, as a researcher, you should not say that this is the absolute model, because you have to keep it yourself open. Maybe for a certain type of application, you require more layer to be introduced. Please remember, whenever we refer to 3-layer, maybe some researcher is proposing 4-layer, and he must have identified certain drawbacks with 3-layer, where his application or a particular type of application cannot be deployed, so one can introduce. So don't close yourself. This is, you can say, by a group of researchers or by a group of scientists where they successfully deployed the applications and get the result. So the top layer is cloud computing layer, where we have huge amount of computing resources, storage, and others. I'll also clarify when I say the resources, what are the resources. Please remember, bandwidth is also a resource, and this networking part which is ignored, that is also a resource, and that comes huge addressed nowadays in virtualization technology. Okay, so broadly now it comes to the cloud networks. Okay, the leader is the VMware, and you'll be finding there is a huge change in deployment and other policies in edge computing, IoT, and everywhere, because the whole network things are getting virtualized. I also explain how it is easy for deployment and management, and all the leading companies are coming with their devices supporting that technology. Now, we are continuing with three layers. One is cloud computing layer. One other is fog or edge. Just I'm writing fog or edge, but when I'll continue, I'll refer to as a fog layer, because I'm referring something standards that the Cisco is using. Then we say thing layer. Okay, so in a thing, we have uniquely addressable devices because they are connected to a network. Then somebody may look into that, how these devices are getting connected. Because in internet scenario, you need a unique IP address to do that. Then when you try to group certain devices into one network, how grouping is done. Logically, we draw a diagram. So one has to know how we are going to use the subnet mask, or how we are creating different LANs. Maybe there are number of one network, you can say it is constituting one LAN. Now it comes to a simple term that is called gateway. Gateway, you remember, gateway is the interface between two local area network. Okay, so logically, if you look into this diagram, this may be network into one. But because of certain application, the IoT devices or edge devices are grouped into a particular LAN. There are many such LANs are existing in a smart city. So you need, they cannot be connected through the one gateway. You may be needing the multiple gateway with different capability so that it can be connected. So always these system models are application specific and based on certain assumption. So when you cannot get a generalized model where different IoT applications are deployed, rather than we have to stick, we have to refer to a particular group of application may require a different type of system model. So anytime you have to discuss any IoT application which is to be deployed on the top on the fog computing, or maybe the resource management of the fog computing, first we have to assume, or we have to agree, or we have to refer to a particular system model. So we are continuing with. So what is the motivation why we are going for this? So this is something, if we look into this predictions, so the number of IoT devices, the growth of the IoT devices, which is going to cross 30 million, which was there in 2020, and which will be more than 100 billion. So all the applications, when the devices are growing, means it is directly reflecting how the people are using, or how the applications will be available on the top of those devices. So that is one of the motivations. Now, if we look into the study and the sources I have put it on 2019, so how the market is growing, how the number of devices are connected, and so this is a forecast. So that is the motivation why one should look into this technology, fog computing, cloud computing, IoT devices for various applications. In addition to that, this also shows for the different type of applications we are using the IoT. Okay, so these are the motivation of why we go for this thing. So something, whatever I have shown in the figure, that is summarized here. According to the research, global fog computing market value is predicted to be 753.6 million USD. So those who are job seekers, those who are professionals, when the market has a volume, money, definitely I'll have a good job, I'll get it. Okay, so this is are the motivations with which we are computing. So as I say, we are continuing with the fog computing of the three-layer model. Now look into the resources, what are they are in the model. So here, the fog computing, first thing is a decentralized computing infrastructure. What I try to say, sometimes we are starting with fog computing and cloud computing without looking into the basic concept of the distributed computing. If you are looking into know the fundamentals, these things are sits on the top of a distributed computing infrastructure or basic principles of distributed computing. So what happens whenever we start this subject or we take up this subject, and sometimes we try to learn fog computing or cloud computing, and we are not looking into the prerequisite. I mean, I think maybe it's not available. So we are not referring to a distributed computing paper in particular. So my suggestion that if you are find stuck up with some issues or you are not getting a clarity, then you have to go back to the distributed computing book or text where you will be finding these things are clearly mentioned. So as per my experience, one has to go for the distributed computing or not distributed operating system, distributed computing. And after that, if we come to the fog and cloud computing, it will be easy. So it will be more clarity. So now this is single terms like data, compute, storage, application. Sure. In fog computing, where these things are located. So this data, compute, storage, and applications are located in between the data sources. Data sources are nothing but the IO devices which are capturing the data and sending to the a computing layer for certain decision. Okay. So this lies in between. So that leads to the logical infrastructure or the extension of the cloud computing as the fog. In addition to that, if you want to refer the model, for fog computing, there is a consortium called fog consortium. Okay. So the fog consortium reference model has to be referred. What I can say, if you are referring to the standard models, go for the standard organization and refer their models, not in particular to a published paper where the model is there. Okay, so this is something more details I add so that you can refer to those slides. The goal is to support new application with lower latency requirement while processing the data more efficiently to save the network cost. So we can formulate our problem with a different objective. Sometimes we may find to ensure a low latency application, maybe we have to deploy more devices, we have to deploy the more resources. So, but objective has to be fixed, which issue I am going to address in the fog computing. So when we look into the infrastructure, there are various basic issues are involved, which is most important thing is the scalability. As you know, the IoT devices are growing. If I have a fog computing infrastructure, I need to ask whether this particular infrastructure is scalable. With change of the technology, there are heterogeneous devices are to be added. As we progress, as we move from year to another year, I cannot discard the particular product which is operational, but I have to acquire a new product. Maybe very simple thing. You say in the change in the technology 4G and the 5G, if you have a wireless access point which is not wireless 6.0, it is not going to support the various IoT devices. That means if you have not deployed a IoT application at present in your organization or in any environment, but you try to buy a wireless access point. So please try to see that your wireless access point will be compatible to the wireless, to these IoT devices. Any devices now it is being purchased by any organization, you have to look into whether the device supports IoT or not. Otherwise, it is very, very costly because the devices are entering, IoT applications are entering, and your network is not able to support them. So there are a lot of heterogeneity issues are there when infrastructure which already with me and IoT applications are coming. Where should I? Is it possible that I can extend my infrastructure so that it can support the IoT application? So this is one of the crucial issues. So that's why those who are involved in buying decision or the devices and others, please always look into that. It will be costly, but simple question, is it compatible to the IoT? Okay, so now to put the data compute storage application nearer to the user requires resources. So what do you mean by nearer? Where that is near is. Let me tell you a very simple example. Let us, we plan a smart home or we provide a particular house with a facility, it can connect 5 or 6 or maybe let us say 8 different IoT devices, maybe your smart freeze and fire detection, all those things. So every house in an apartment, I am going to provide a wireless access point and to which these IoT devices can be connected. As I say, I have to go for Wallet 6.0. Then the whole building is going to form a network, local area network or a LAN. Then to route the information for decision making, for computing, so I am going to fix a gateway there, right? So these are the resources I put on a building or in an apartment. Now, where is my fog layer has to exist? Where is my fog layer has to exist? Then I am connecting this to a particular or I mean, if I am on a backbone and with the internet, maybe I am going for a ISP. Then suddenly ISP people are offering, sir, we have computing resource. Once you upload the things, if you want to do little bit of computing, I can support you, right? Or maybe you are connecting to the infrastructure which was earlier a network infrastructure to provide you internet connectivity to a locality. And locality has 5 to 6 buildings. And every building has to access the internet through that particular ISP. So some physical infrastructure is there. What happens in the past, those infrastructures are only capable of providing, maybe you have the firewall and others, they are networking resources mostly a distribution switch or a core switch is there. So now these core switches, do they have a capability to do some computing? The answer now comes yes. The devices are being designed through the virtualization technology. A virtual machine will be available to cater your computing requirement. So how the virtual machine will be created? Virtual machine will be created. It requires certain resources that I'll explain you. And another challenging is that you want to do X application. One building has got X application. Another building has got a Y application. So X and Y applications have different resource requirement, maybe different software requirement. So I need 2 virtual machines to be created on that same particular device or the edge device, or you can say just a ISP, you can say, which having the core switch. Okay, so there if I can create some computing resources and if that is get computed there and I can get the result, so that will be my computing requirement. Okay, so this is the way it moves, that when we talk of the data sources, storage, application, so how this has to be run. So virtualization technology is key for deployment of virtual machines or creation of virtual machine on the top of, you see, on the top of, maybe it will be top up on the top of the switch, maybe in the top of your gateway, maybe in the top of your router, anywhere, whatever the resources are coming. So that's where the system model is important to us. Okay. Now this is a logical diagram, and immediately, as I have explained, I have different IoT devices, and those IoT devices form a group. As I have N circle, you can call it a local area network. Okay, in a local area network. And I can give you one example. Let us say in a campus, you have a group of devices. One device is like we take a biometric attendance, we form a particular VLAN. Then we have camera network, we form another LAN. Then we have some user terminals, we form another LAN. Okay, so that our current networking technology supports, I can create a VLAN. If you have a network infrastructure, if you have trained people with network management software, they can create 3 different VLAN, but logically they are part of the single local area network. This I try to say, suppose in a building you have 100 flats and they are using 3 different types of application, and those applications are used by various users, then I am going to form different LANs and connecting those applications. Now, look into the fog node. The fog node, some symbols are there which indicate some storage, some security solutions, some components are available. Yes, those physical infrastructure has to be available at the edge. So this is not the logical infrastructure. Physical infrastructure has to be available. So it's a revolution that earlier those, I mean, just like I give you the example of the ISP. ISP people, they do not bother about the computing infrastructure because they hardly has got a core switch or a distribution switch, or maybe if you look into a campus LAN, you have a networking infrastructure. whether it is a layer 3 or layer 2. Okay, I am not going to complicate that. So, but now the resource requirement is there. So there is a growth of the resource requirement, or one has to add the resource. Now, as the fug node has the different activities to be done, if I try to put a dedicatedly a computer for that, it will not be used. So mostly sometimes this gateway and other devices, they are now made available by this company which is capable of doing those things. I'll show you the example how the Cisco provides the hardware for that. Okay, so when you look into the fog computing infrastructure, a device with computing, storage, and network connectivity can be a fog node. So where that means I have to put the new devices as a fog node. Answer is yes. And that means if you are looking into the present scenario or designing a smart city infrastructure in a city, then definitely you have to create a fog computing layer. Okay. Then you want the data to be backed up and a lot of analytics has to be done. So your data will be also uploaded to the cloud where it will be safe and a lot of analytics has to be run there and small computation will be up to the edge. So the example includes the industrial controller, switches, router, embedded servers, video surveillance camera. What I try to say, these devices earlier comes without any computing capability. Second, sometimes even if the computing capability is there, it is for a specific application. Now, with a virtualization technology, if I have an industrial controller, I can create a virtual machine on the top of that, and I can use those virtual machines as per my application requirement. Again, let me clarify. Let us talk about it in a virtual machine. I need a computing machine with 2 core and 8 GB memory. And you need another virtual machine with 1 core and 16 GB memory. So I am in a position to create 2 virtual machines on the top of that particular gateway, sometimes on the controller, sometimes on the top of switches. Okay, that requires this type of facility must be provided with the switch. Okay, we'll come to that, how it has been provided, how the hypervisors are built into the switch, and the switches are ready to host the virtual machine as per our requirement. Okay, so there is the 2 things go simultaneously. The resources must made available. We mostly talk about the application, others, or maybe we are talking of different algorithms, how decision has to be taken, but everything is subjected to the resources available. So resources, what are the available currently with industry, what is their capabilities, always to be referred. So what I can say, by simply sketching this diagram without knowing the resources, if you try to design or address a issue which may be only theoretical, and when you try to go for a deployment, you will face those constraints. Okay, so knowing the actual devices which is available, you have to refer to any networking company. Maybe you look into their switches, gateway, and others. Ask that whether it is suppose virtualization, you'll be finding it is there in the catalog. Then what is the capability, how much memory is available, which processor is available, what type of storage is available, everything will be there. And if it is going to meet your need, you can go for that. So this fog computing was utilizing the local devices termed the fog node or the HDD. So, and these devices, if you look into the present infrastructure, if you do not have such type of devices with computing capability, then you have to specifically purchase the devices which has got dual functionality. It is going to cater your network functionality as well as it has the resources where you can do this thing. You can do certain compute, you can do some storage, and you can simultaneously also you are going to do perform something, some network activity what your traditional switch or gateway was for. Okay, so this is again a diagrammatic representation. You look into the fog layer, what we try to do. I'll be talking about the hypervisor virtualization technology, which was key to the cloud layer. That means we are creating a virtual machine on top of a physical machine with help of a software, with help of a middle layer, whatever you can say, it's a software that is a hypervisor. Okay, the same capability, as we say, the fog resources we are bringing close to the IoT devices or IoT users, the same capability or same virtualization concept has to come to the fog layer. But there in cloud, the resources are bulky. The servers are with high capability in terms of compute, storage, and others. But in the fog node, the resource or the computing capability or the resources are small, very, very small in comparison to the cloud layer. So we have to again look into the virtualization technology. Maybe you can say if your virtual machine is application which takes a huge space in the memory space to provide the facility of creation of virtual machine, we need a smaller or a miniaturized version of that hypervisor so that I can create the virtual machine in the fog layer. Okay. So sometimes you'll be finding why there are two fog groups are logically, two diagrams are created. You see, this is for a particular application. Suppose for a group of particular application may be catered by a, maybe I can say the word, suppose you have a telephone exchange or those who are providing like BSNL provides you internet. Let us say they're all ISP providers to you. So they have an infrastructure. So these fog nodes are going to be created on the top of those devices which are available with that telephone exchange, or maybe traditionally we have the switches and others there. Now those switches are with computing capability. I'll also talk something about the switch also. If you look into a typical switch, let me clarify. When we look into a typical switch, which is not, I have not included in this presentation. So in the switch, you have a processor, you have a dual power supply. Mostly the switches, the traditional switches, we have the softwares built into the firmware, and the switches started himself. Once you start, it starts. It boots like loads your operating system, and the switch is ready to receive certain commands. And whatever the functionality a switch can do is inbuilt into the firmware. I mean, the applications what a typical switch executes is fixed into, built into that hardware. But whereas in the present scenario, our applications are different, depend on the different users. So we are not going to do that. We are not going to fix the set of applications into a switch so that only those routines will be executed. Let me again clarify. Suppose you know what is a best routing algorithm, and that will be stored in a firmware on a switch, and that executes on the top of the processor available on the switch and gives you decision. Now, your applications are different. You want to execute your own application to take some decision on the top of the switch. So I must have that flexibility. Okay, that is available with the switch. If possible, maybe second section, I'll show you something details on the switch to clarify, but the present presentation which I'm using is not with those things. Now look into that. This is the three-tier mechanism of the fog landscape. Look into each and every word. The bottom layer are mostly connected through the wireless. Bottom layers and IoT mostly connected with the wireless. I just told you, if in a building, if the many applications are running, or in a city, let us say, we assume that there are three different applications, and one is the healthcare application, one is the vehicular traffic management, another is the smart home. So there are three different gateways through which it is connected. Why three different gateways? Because to cater the computational requirement, the resources available in the fog node are also grouped into three. This is a logical grouping, because the application or the service request which is coming from the smart home goes to one set of fog computing infrastructure which is going to cater the need. Okay. And this changes dynamically. Suppose say tomorrow one more application available on your city. Then you may have to take the resources, or you may have to create another cluster of the resources in fog layer so that it is going to serve it. Or maybe this, what you are finding, there are three groups showing the computing and storage. They may be again rearranged to form the fourth group, because immediately you are not going to add the resource to your fog layer. So they can be grouped into four groups. And sometimes one application stops and resource requirement reduces, then maybe those resources will be again reorganized. Okay, reorganized. Okay. So this is the fog type. I hope you'll get a clear picture. It requires the resource, compute and storage, you can say. Now, there are, when you are collecting huge amount of data and others, which may be required for some certain future forecast, or maybe sometimes you can look into using designing intelligent application, working on those data to take a better policy decision. So because the fog node has no capability, I mean, has very less capability of storage and others. So after giving the decision to the applications, those data are stored into the cloud, because the cloud has got a, you just assume that they have got a huge resources. Okay, now I'll give you a very simple example how this works. This is, and many companies, they have already started these things. Let me give you a small example of a wireless controller. And if a wireless controller has to be deployed in the previous, I mean the old era, maybe before 5 years or 10 years, we need to buy a hardware controller. What I try to explain with the virtualization technology. We are going to have a hardware controller. If I want to put 48 access points or maybe 5 access points in my campus or in my building, then I have to buy a hardware which supports that. Okay, it is definitely multiple of 8. So I have to buy a controller that supports 8, 16 or 48 or like that. Okay, so I have to buy a device, I have to do the installation of that device, and then when I have to install a wireless access point, I do the necessary configuration with that controller with help of the network management software associated with that. That is, physically I am connecting my wireless access point on my local area network backbone. I do the logical configuration through the controller software. Okay. After that, these controller people says, okay, you do not require, and there are many challenges, many wireless controllers are there, so scalability is not there. Okay, if you say no, we can address maximum 96 nodes, we cannot extend. This is the practical experience I'm telling you. So then a few company comes, okay, you don't need a hardware controller, you go for a software controller, right? You go for a software controller. They provide a software controller which runs on the top of a machine, maybe physical, maybe a dedicated machine, maybe a virtual machine, choice is yours. So you run that particular controller software on your institute premise or in your network center, and you go on connecting the wireless access points, because when you purchase a wireless access point, there are certain information available on the backside, and why I say certain information, now things are more simpler that companies are saying, okay, you don't want to know IP address, MAC, etc. Simply put the serial number, it will be added. So simple, and that is the next stage. Then the next stage, they say, okay, we don't require your resources where controller has to be executed. We have already designed the controller, it resides on the cloud. And you just buy the wireless access point, connect them to the physically to your network ports in your campus, and you do, and you can create immediately a account, and in that account all your devices what you purchased can be connected. Why I am critical about those wireless access point again and again, because these wireless access point must support the IoT device, otherwise your IoT device cannot work, right? So that's why it is connected. So they created, now it is a totally in the software control. Now totally is a software controller, so they provide you user controller. And mostly those companies are using a very small server where they provide that software access to you, just like your email and other storages what people are providing, right? But few companies has come beyond that. Okay, few companies are coming beyond that. They say we can do some intelligence for you. We know your network traffic. If they are doing it for network traffic, tomorrow they are already providing how your IoT devices is to be better managed. Okay, some IoT devices are continuing capturing the data, some IoT devices are periodic capturing the data. What these people are doing, they have the controller with the cloud. And that controller is an intelligent controller. It captures the behavior of the devices, how the network traffic characteristic, what decision you have given for routing, everything is captured. And that's why the last layer you see, you may ask why those data are again goes to the cloud layer. So as I am explaining, for, let us say for a network management, whatever the activity is carried out on the success point, let us say in a campus, goes to the cloud. And let us say in this week, you use certain policy which is fixed for your controller is being used, and they are meeting certain quality of service, but they fail to do so. I mean, they are not able to meet. The next week, what will be the policy? That will be decided based on the learning of the last week. Next week policy will be decided. So they run the intelligent application on the backend. They change the policy through which your controller operates or a cloud controller operates, so that you can get a benefit of those policies. Maybe they have a SLA, maybe you try to minimize the latency. Maybe the decision will be like this: instead of the 3 fog gateway, you require 1 fog gateway is to be created. But where will you get the device? It will be again logically created. Sure. So for those type of decision and computing, if your application supports, we need the cloud. Okay. Now, again, some people try to do that type of bit of learning for certain application. They try to put those capability to starting from the IoT devices to up, every devices. Can I do some learning with my camera when I am capturing the image? Can I do the feature extraction there? So yes, those things are also in discussion. Devices are coming. So these all possible with virtualization technology. I'll explain you how. Because if I am capable of creating virtual machine as per my computing requirement, I can use that. So virtualization technology is key. When you have a set of physical resources and you are creating virtual resources as per your application requirement and dynamically configuring the virtual machine. So why again virtual? I told you something about distributed computing. You see, when you look into the quality of service, maybe I'm talking of resiliency or fault tolerance, scalability. So these are basic properties of the distributed system. So what are the basic properties of the distributed system? I mean, the benefit of the distributed system, it has to be reflected on each and every layer. That is on IoT device layer, fog layer. Suppose one of the resources fell in the fog layer. How you are going to suffer? Answers would be no, I am not going to suffer. I can have the different type of configuration and I am going to meet that. So those basic characteristic of distributed computing has to be reflected in every layer. That is the reason I say if you are a researcher and looking to do something different, then you have to go back to the basic to know what is a distributed computing. Now, so I'll be quickly covering a little bit of cloud computing. I used to do that because cloud computing, we used to refer to the books and the research paper and others. Okay, fine, you can refer, but the good reference is the NIST document. NIST is the US Department of Commerce, which has the standard document of the cloud, and that will be the best reference model, and which is characterized by 5 essential characteristics, 3 service model and 4 deployment model. Other models, whatever things are coming, is an extension of that. Now let us go back to what is this model. You see, you'll be finding cloud computing is a model. That means it has to be, and whenever you also address, you have to write your own model. You have to write your own model. Maybe you can come with a new model, finding the shortcoming of the existing model, which is not suitable or not able to meet your requirement while you want to deploy a IoT application. Now, we look into the particular terms. Networks is a resource. I'll explain you. Networks is a resource. Now, network virtualization and a term is involving cloud network. And you see, if you heard of a company like VMware, they have started the concept and they have deployed it, and they provide this as a solution. Okay, they were earlier providing the software for virtual machine creation and management. Now they did completely virtualization of the network. Okay, now the servers, what I mean to say is a computing capability. Now there are 2 types of servers. One is CPU, one other is GPU. Maybe you can say a supercomputing capability and a GPU capability. Then storage, independent storage units are there, and they are being connected to the computing resources with a particular network, which will be called SAN. and then the applications, depending on application, we create a different virtual machine. We dedicatedly run the application on the top of that. Then the services mostly it comes from the particular software that manages your server farm, manages your resources. Maybe that is a network service management module or a virtualization service management module, like I say, like the VMware and others. Maybe network service management module. Suppose you have a core switch, then core switch has to come with a network management software module. So these are called the services. Okay, so quickly we move into that. You look into that. So one thing I want to clarify: if I try to create a virtual machine, you see why I am talking again and again. If I want two IoT application has to be run at a particular edge or a fog layer, then I need two virtual machines to be created. Okay, two virtual machines is to be created by taking the resources what is available on that machine. That is the constant. If I have a single core processor, if I have a processor with 4 core, then 4 core I can give to 4 logical machine, right? So then my main memory, the main memory again is a constant. Main memory is 16 GB. It may be, depending on the application, it can be 2 to 12 or maybe 8, 4, 4 like that, depending on that. Then next interesting, similarly the disk, the storage. Next interesting part is NIC, network interface card. And another thing is IP address. When you are going to create a virtual machine on the top of a physical machine is already connected with the internet and it uses a particular IP address. Now, when you are creating two virtual machines, those virtual machines are to be projected as the independent machine to the rest of the world. So when the two machine will be looks just like an independent machine to the rest of the world, they also need a IP address. Okay. So if you are creating a virtual machine, then you also need two public IP which is to be attached to these two machines. That is, while creating the virtual machine, you also need a public IP. If you want, you people can access your virtual machine directly, then you need a public IP for that. That's why the network interface card is figure. Maybe it is not properly explained on the books. So that's why network interface. Physically, one card is there, but logically, again we attach the public IP to virtual machine so that you are independently accessing the virtual machine. Okay, now something is there here, EXX server. So that is a virtualization layer. We'll come to that later on how the virtualization technology is there. So the physical server is a piece of equipment where data stored and read. This may be located on your server room or may be located in a co-location facility in data center, or it may be located in a cloud. So anywhere I can do the virtualization. So this says in my edge layer, suppose I have a physical server with certain computing capability, I can create many virtual machines as per my IoT application requirement, so that those virtual machines will be dedicated to different applications. They will facilitate the execution of the application and serve to the users or serve to the decision makers. Now, just what facilitates that? You have a physical machine, you install the operating system on that. It's an old concept again nowadays. Then you go for another software that supports your creation of the virtual machine. Okay, so VMware hypervisor. VMware is the company. They have a hypervisor. After installing the OS, you install the hypervisor, which facilitates you creation of a different virtual machine. So you can create a finitely many number of virtual machines subjected to the sum of the resources requirement by the VM should not exceed the resource available with your physical machine or your host. Okay. Now, the present, because we need the virtualization is becomes very common, then the companies of VMware, they are proposing why to use a host operating system. So directly physical devices are coming where VMwares are preloaded or it's a part of the machine. Once you start the machine, the VMware is ready and it facilitates you to create the virtual machine. The same thing happens on the switch or the edge device. So VMware is the part of the switch now, and when the switch starts, it is ready to perform something. Then maybe a switch starts, one VM is created, and that VM dedicatedly is the in-house management of the switch controlling other functions. Then you have enough opportunity to create other VMs as per your application. Okay. Now, when you look into the cloud computing, we talk about three models. That is the basic, and one must know that is essential characteristics, service model, and deployment model. Okay. So, and why we are looking into this? Suppose a particular IoT application, and when you try to deploy the IoT application, you may be looking into certain services in the cloud. There are challenges will come. Maybe somebody say, what will be the challenges if I want to deploy the IoT application on a hybrid cloud? Why hybrid? Your smart city is expanding. You take the service from started with a one cloud service provider. There are few services which are coming. That cloud service provider is not going to support you. You try to take the help of another cloud service provider who is best providing that service. Now, because this has to become under a single administrative domain, then you say, okay, you create a hybrid cloud for me. I'm taking some part of the resources from Majan, some part of the resources from IBM, but I want a hybrid cloud for my smart city. So then this application challenge, sometimes the different applications uses the different API, they have a different server, so they have to handshake. And so these are the things one has to know when we're looking into the application. Okay, not say you have to know all those things because these are connected. Because we hypothetically, if you say, okay, my application, it goes too far. What is the scalability? No, maybe tomorrow you will need certain application. Maybe let us look into the security issues. And you must have seen all the banking softwares they use the security, third-party security. And those third-party security runs on their server takes a decision. So there is a handshake. There is a compatibility between the application software designer and the security people. Okay, so that's where the basic model has to be referred. I have just put all the details, the 5 essential characteristics. So on-demand self-service, broad network access, resource pooling, rapid elasticity. You see, this is a very good problem. You look into any IoT application deployment, any service application deployment, you propose a solution, one can ask whether you have addressed this issue. When the number of users grows, your resource scales. When number of users are not accessing, it goes back to the original. That means you are creating the virtual machine when applications are running, and maybe in the late evening, nobody is using those applications. So then again it goes back. Elasticity, just like a simple rubber, you stretch it. When you leave it, it backs to the original position. The same thing happens. VMs are going on creating to meet the requirement because you have a certain SLA. Okay, number of vehicles are busy in the road, so number of VMs are created. Vehicle is reducing, so number of VMs are closing themselves or killing themselves, right? And another thing, and there also we need a migration. You create 5 VM. Each VM is capable of taking care of 5 vehicles. But after some time, you are finding there are only 10 vehicles are there. Let us assume that each VM is now only addressing 2 vehicles. Okay, so what can be done? Then you require only 3 VM to do that. So some of the application has to be transferred from one VM to other. So some migration is required so that the 5 will not work. They will not consume energy. They will not consume the resource. I mean, mostly the energy. So what you try to do, the application which is served by first and second may be merged, maybe third and fourth is merged like this, and you have to manage with 3 virtual machines. So those things are also related because this virtualization technology is key for the application deployment, resource management, fault tolerance, availability, scalability, etc. Okay, the resource for extra resources are self-managed. So this self-managed is nothing but the software module which is created as part of the managerial node. I'll come to when we talk about a controller, what are the functionality of a controller? We say FUD controller, cloud controller. So how the controlling function is such. Okay. So major quality of service levels a quantity and qualitative metering capability, making the user-based billing. Because you see here, one thing we say, whatever resources is used, you have to pay. So there is a mechanism we try to assure the user that you are going to pay as less as possible. That requires the resource management. Moreover, the resources which is utilized is also measurable. So these are from the NIST document. And similarly, if you look into the service models, they basically talk about 3 service models. So why it is critical? If I look into an IoT application, if I'm looking into a gateway, so in gateway, it's the infrastructure. You are buying a gateway. You are buying a gateway. What the company provides? Is it provides, you treat the gateway as an infrastructure or a platform or a software, right? If you are going for a specific type of IoT application, maybe your gateway is ready. Maybe it is coming under as a platform where you can only deploy your application data. Look into that. Now you are smart enough, you buy a gateway, you are capable of installing all those things, doing all the configurations and capable of managing the gateway, then everything you do at your end, so you have absolute control over the resources, or you can see the responsibility of managing network, storage, all the virtualization. So that is a software as a service. But if you look into the requirement, you see, mostly one can look into this platform or the software, everything is bundled. You buy a specific gateway which supports your particular agriculture, or maybe you want to do the water management for a lot of agriculture lands. You completely becomes as a stack. It's only acquires the data, application is also fixed. Okay. So this is also can be explained with the 3 basic models. This is the example when we look into the cloud platform. Again, I repeat why it is required. These things, again, I am pushing into the edge. So I'm not doing any extra activity. Whatever the functionality is being offered at the cloud, the same functionality is available at the edge, and I mean the fog layer, and with less capability. Less compute, less storage, but all the facilities are available at the edge layer. Okay. So here actually the diagram which I have referred, you see, if you are saying that you are going for a Cisco and you want to do a specific application or a specific industrial IoT, you try to look a model. Okay, you provide us everything as a stack, only I'll connect, my data will be captured, and application also designed by them. Okay, now you look into that, that is the way it is differently colored, how the vendor manages, everything is inbuilt. Now, you are doing experiment in the lab, you try to deploy various applications, or maybe you want to use your fog infrastructure for different application. So you are gaining the control. Look into the middle model, platform as a service. You are gaining the control in terms of data and application, and how the edge device will start, how virtualization will be created. Everything is the responsibility of the vendor, so they inbuild the device into that. Okay, so that's why it follows the basic concept from the cloud. Okay, now the third point, the 4 deployment model. Okay, public cloud, private cloud, community cloud, hybrid cloud. Mostly, if you look into that, and if a data center is in operational, one cloud service is installed for a small city, but for certain services, they try to help at the help of the Amazon and others. So here, what you have to do, and you have to go for a public cloud, and you are having a private cloud which is to be used by your own organization. You want to do a hybridization so that best services you can take from the best cloud service provider, and in addition to that, the resources in your data center or in-house computing capability has to be used. So that is the hybrid computing model, which is sometimes essential in the cost point of view. If you are starting at a fresh, then you may deploy everything put on the a public cloud, and you can do that. Maybe you are going with Amazon, or you are going with IBM, or you are going with Oracle. They are all cloud service providers nowadays. So, or maybe sometimes you have to go for the hybrid cloud. Okay, there are certain constraints in terms of the operating system, in terms of the software what we are using. If you, and those service providers, like suppose you want to go for the Microsoft, they want your own infrastructure or your own public cloud or the infrastructure, in-house infrastructures must be compatible to the Azure and others, so that they can integrate extra resources from their data center if it is required. That means your computing infrastructure in-house will scale, and as per the resource requirement, those resources are not with you, but with the Microsoft Cloud. Okay. So the same concept, I mean, these things are essential for all these IoT devices management. Then there is one interesting term I want to explain, the way it moves, because I have to give you an example what Amazon Lambda offers in terms of the IoT or Amazon Greengrass. So here, next concept which is quite promising nowadays, serverless. Okay, so I want a particular IoT application to be deployed, and I am looking for I have described my requirement of my IoT application, and I demand a serverless architecture for that. Am I getting the answer? Then how you will get this answer? If you look into the recent trends, we are actually migrated from traditional physical data center. We come to the virtualization. Now we passed the virtualization. Then comes the containerization. Now we are with the serverless. Again, I am repeating the question. I want to deploy a particular IoT application. If a person who understood the serverless, you are asking me, can you design me architecture for a particular IoT application? Let us say healthcare application. I want serverless architecture for IoT application. Okay, and if you look into the products or applications which is available, these serverless are already available with Amazon. Only Amazon I have study. It is very easy to see. You can open an account in AWS. AWS, you can open an account. Don't enter your credit card number if you are not going to use. Just log in to see that what are the bundles available to support IoT. It is in my presentation. I'll discuss. Very simple thing, and there you'll be finding this word will appear, serverless. Serverless. We talk about servers, a complete serverless. What is that exactly? So it is nothing but your application requires a set of functions. Why should you bother about memory, CPU, IO? It is not your botheration. You say my IoT application required 10 functions. I will make a bundle or a package. I'll give you 10 functions. You use that function only. It is not your botheration to look into infrastructure or physical infrastructure, network, bandwidth, etc. So slowly it becomes a black box. You can say you are concerned with the application. So that is now the present trend, not exactly present trend. It is already operational, but it's one of the promising area to look into the serverless architecture for any type of IoT services you want to do it. Okay, serverless again is a long topic and we are not going to discuss. This is actually, we started with virtual machine. I talked a lot of things about virtual machine. Then intermediately we got the containers. Okay, containers are actually taking those resources and others, little bit of resource, and for a specific application, I have a container. You put your application there, your all things will be solved. Now, it slowly moves in terms of functions. Or rather than they use a term called function as a service for the serverless. That means for an IoT application, if I am going for a serverless infrastructure, I can say, can I have a serverless infrastructure in my edge layer to solve the application? Okay. So that means the set of functions only that is required for execution of my IoT application will be available to me. I'm only visualizing in terms of application. I'm not visualizing in terms of resources. Let me give an example. Suppose you want to use a mathematical library, maybe Sinex and POSIX. You do not know what is the floating point processor requirement, how X is represented with a double or long double, what is the best algorithm runs in the backend to calculate the Sinex. But you know, Sinex is a function, it is required for me, I will be using. So that is a function as a service is key to design the serverless infrastructure. And as you have seen, you look into that, this slide I have taken from the AWS, and Here in the bottom line, you see, as we are moving towards the serverless for IoT and others, these are being managed by the CSP or cloud service provider. You look into the bottom line, up to the container, you have some say. Customer manages the hardware virtual machines which I have talked to. Once it comes to serverless, everything is managed by your CSP. They know what are the optimal resources that can be made available and where those functions is to be executed. So it's a black box to you. So there it leads to two domain knowledge is required. One is the software architecture, then a microservice architecture. These are the key things if one can learn. When somebody is talking of IoT device, this fog computing environment, one can look into the fog computing in the light of microservice or in terms of the serverless technology. Okay. Now, another thing, when we try to get the details now of these service providers, hardwares, everything, I think many people knows, we always refer to the Gartner. Okay, Gartner is a US agency and there is a technology leader. They forecast, they benchmark, they standardize the different vendors. Many of their forecasts through which the industry moves. If they say machine learning is demand, people notice that. If they say business algorithmic is the trend, so people follow that. So anytime if you are looking into a decision that which type of IoT devices or which type of fog computing infrastructure, who are leader in fog computing infrastructure, then we have to refer to the magic quadrant of the Gartner. Gartner has many magic quadrant in terms of the services. If you look into a cloud infrastructure, this is the magic quadrant. You see there are 4 quadrants. The top quadrant or the leader quadrant, you can find Amazon, Microsoft, Google. So these are the top web service, you can say the cloud infrastructure or a cloud service provider. Then followed by that, there is a challenger, which is empty. The visionary may be Alibaba Cloud, it's like that. Similarly, if you talk of a IoT gateway, if you talk of a edge devices, you simply browse it with a Google with this Gartner benchmark and take your decision what type of standard products are available, who are the leaders, and then you have to follow. Their white paper and everything is available. That will give you clear picture. I'm telling you very openly. Sometimes this journal paper and others maybe they are a little bit of far away from the practical implementation. Mostly, sometimes people says they do not know how a gateway looks like, but they talk many things about a gateway, and they deployed certain algorithm. But to know a little bit of close to that will definitely help you to visualize the problem in more details. Okay. So we'll continue with the fog computing infrastructure, and maybe in IoT devices we have a smart TV. Now you look into that. When there are number of IoT devices are there, so suddenly we are introducing one concept, fog broker. Yes, it is again a software. Maybe the requirement of from the IoT devices comes. So the fog broker is trying to acquire the resources, or there may be fog service provided by, in your locality, fog service provided by 3 different players, and maybe a fog broker is receiving, and you try to pay as less as possible for the computing services. So the fog broker offers you who are going to provide the best service, and they logically combine those resources and available to you. So this fog broker or the cloud broker which I am shows, it's a one type of manager, or you can say controller. And if you are looking into their architecture or their functionality, that is also one of the area. That means if you say I am going to design a controller, what exactly a controller? I am going to design a controller. Again, I ask, what it is exactly a controller? To controller, I am providing certain functionality. Okay, I just propose certain functionality which is required so that a node can act as a controller which will meet this requirement. It will provide the services at a very low cost, or the whatever the cost of the application executed can be minimized, or it is going to provide me the right resources so that I can meet the latency which is permissible to me. So this is a controller. And to design a controller or to propose a IoT controller, a FUG controller for a specific type of IoT devices, you require in depth, I can say, the object-oriented concept, because it's a software. It is a software with certain functions, and those functions accepts the input from your IoT devices, and they execute to give certain decisions. So here, object-oriented concept goes very closely while designing a controller or set of the functions. Another thing I can say, when we try to simulate or compare different algorithm, and we say this algorithm is best. After that, we could not say where it will be used. Suppose I am talking a routing policy, and my routing policy is being done by one of the controller. So I have to find out the best routing policy, and I can then say this routing policy is to be used on the top of that, but as a function of that controller. Okay. Again, I'm
मुरबी लोक गोटे एमसीए परिवार मुरबी लोक कथा Ashish Kumar Raut ji, please mute your system. Sir, please continue, sir.
Yes, thank you. So when I talk of a controller, you see these are set of functions. Maybe let me simplify. You have sin x, cos x, and others. You developed a very good sin x routine. That will be part of the controller. Maybe a routing policy, maybe scheduling policy, maybe resource allocation policy. So if this broker or the controller who is going to receive this thing, he has to take a decision as per that algorithm. Okay, so logically when we are working, when I'll go depth, I'll show you that different issues. In different issues, we try to simulate different algorithms, taking the help of a lot of simulators available. And finally, we come out with this technique is best. After that, it is our accountable to say where these techniques will be added. My controller is going to perform 10 functions. Now I am finding which is the best function one. And that best function one I am deciding through certain experiment with help of a simulator. Maybe those functions are different for different application. Those functions are different for different resources available, like devices with more memory, devices with less memory. Let us say we have our device which has enough memory to buffer the data so that it can do certain type of pre-processing and send to me. There is a device which has got less memory, and every clock cycle it has to send the data because it has very less memory. And another device which has a large memory, maybe he is capturing the data for 5 minutes, then sending in one cycle. So with this constant, we need to recommend which one is the best function. Best function, I will say, it can be a very simple send and receive function also. Or it can be a very simple function. What type, when you are doing a communication between your device, are you using any error checking protocol? Are you assuring that the data which is received by the cloud layer is correct? I mean, like you are assuring that the data is not corrupted, or maybe you can again come into various type of threads which is there in that layer. So all those functionality you can add to that. That means this particular, suppose there is an encryption. Let us say there is a simple encryption. Your IoT device does some encryption, and your FUG layer has a facility to check that this is the specific data from the specific IoT device. Then you allow those data to go to the server or to go to the FUG resources for execution. So this again comes, even the security function, everything comes into that controller. And depending on the functionality, you can designate many controllers. You can call them broker. You can come down in general FUG controller like that, which is very key to the to connect between the IoT device and others. Okay, now here we are talking of a specific device where the controller, again, where that controller has to run. Where that controller has to run. The controller has to run on the top of a virtual machine, because this gateway supports creation of multiple virtual machines. Now look into that. This diagram also clarifies a little bit of much detail. So we have one node here. We say call it a FUG gateway. So FUG gateway. What are the functionality FUG gateway does? How many controllers are running on the FUG gateway? Maybe I have two different type of application. I need two different controller to be run on the FUG device. So or on my FUG gateway. So my FUG gateway must have the resources to run to create two virtual machines on top of which two controllers are running, and one is going to take care of a healthcare application, another is going to take care of a vehicular traffic information. Okay, so this is another way one can look into this. So this is some basic comparison which is copied from the resources. So here the data acquisition and pre-processing. Now you see we are talking of two functions: data acquisition, pre-processing. Do you want to do some pre-processing at the gateway itself? Choice is yours. Before the data goes to the server, do you want to do the pre-processing? If you have enough computing, do that. While you're receiving few data, you do certain pre-processing. It will definitely reduce the latency. Okay, then you have a lot of devices, you are monitoring their conditions. If a device is not available, you are assigning different resources for that. So whatever the functionality you want, you can make it. So now those functionalities are not built into the hardware. Now those functionalities are the softwares, and the user has a liberty to deploy different applications in terms of functionality. That's why I say logically, if you design, these are the functionality which is best for my IoT application to be run on the FUG controller, then that is also one of the good work. And maybe you have to specify that particular function which is to be performed, and then with help of the function you are explaining how your device and how your application will be executed. Another thing which I want to add, when you are looking into this, we read a sequence diagram and others while studying the software engineering and others. So suppose you want to look into a particular IoT application, you want to explain in terms of these three layers or what happens with that. So you need a sequence diagram showing the resources on the top so that you can easily point out that which resources are going to offer what type of function. If a particular layer offers a function, then that will be the function associated with the application running on the top of that. Let us look into that. I want to IoT devices try to communicate to the FUG layer. You want to send the data. So my question will be, which type of protocol you use? Suppose you want to say that I want to send the data. Maybe you are sending a request. If the request is granted, then there is another function with the controller or with the FUG gateway. The request is granted. After the request is granted, you send the data. After that, if there is error correction, and if the data is found to be correct based on the checksum and others, your FUG controller say, yes, I have received the data correctly. Or in between, you know, there are different type of error control protocols. So those are the functions. Okay. So this is the benefit, as we say. There are certain things which is not being addressed. The clouds are location aware. Answer is no, not suitable for real-time application. I'm not going to address the mobility, but whereas the FUG is going to address all those things because the resources are very close to the data sources, and because of that only we are able to meet the location-wise application or a latency-sensitive soft deadline application. In general, we call it as a real-time application. Maybe if somebody is talking of hard real-time application, there may be a dedicated resource provisioning for that. So I have not included those discussion here. Otherwise, those things are overcome by the FUG layer. So when we talk of a FUG layer, it is a set of resources that includes the computing resources as well as the network resources that supports the acquisition of the data from the edge devices and storing them temporarily, maybe summarizing the data. Maybe you want to filter those data which is not critical for you before sending to the cloud. Why so? Because cloud will charge you the amount of data you are going to store in the cloud. Maybe the result of the decision which you are taking time to time, you want to store to the cloud so that in the backend those things can be mined, or those things can be lead you to the designing an intelligent application. So key to this diagram is that there are two things, less distance and more distance. So that helps us to latency sensitive. So the IoT challenges that has been addressed by the fog computing is that latency constant because the resources are close. We are going to make it network bandwidth constant because when many devices try to upload the data to the cloud, you use a huge bandwidth. Okay, so that is being reduced with the fog computing environment. How it is being reduced? Because if you do certain pre-processing, if you do certain pre-processing at the edge and others, if you are going to reduce the data volume, but you are doing pre-processing and you are also meeting the requirement for decision making. You are not eliminating the data so that your decision is going to be hampered. But data requirement is less and uninterrupted service because when you are going through the more layers, you have more challenges in terms of network. When you are going through the one layers, maybe you have less disturbances. Then IoT security challenges. The security challenges, as I have said, there is a particular area called device fingerprinting, and you want to identify your device, whether the device is genuine or not, and then you capture the data. As I say, if you say this is as a function, as the part of my IoT gateway, so I can recognize my device, then I can receive the data. Okay, so application of fog computing in IoT, this is mostly for specific applications, how we are going to deploy it. Now subjected to, of course, what type of resource requirement, what type of corrective service, whether the application is scalable, whether the application is fault tolerant, all the things can be addressed looking into cloud computing environment. Okay, and there are the two things is, as the decision has to come from the edge layer, from the fog layer to the device layer, because you have to give certain decision. You have to give certain decision. That's why it is critical. Sometimes in the cloud, we did some storage, we upload the data, there is no decision immediately required. So that's why most of the applications actually requires a decision, which decision is delivered by the fog layer and to be executed at the at the IoT devices. So that is one more function. And maybe the decision which you are giving to a particular device, if that is corrupted, if that is not secure, so it opens a many issue. Then because you are very close to the resources, you can go for the replication of resources. If one resource is delivering the decision is not available or the trustworthy, you can put another resource. Various security things you can do. Again, if you are looking into the security issues, my experience is you have to refer again to the distributed computing books. So typical security scenario, how to authenticate a device, how to look into the different type of communication is discussed in the base concept of distributed computing. These things are inherited only to this. But when you try to look into the fog computing or various IoT application management, this is nothing novelty on that. It is a basic things is discussed in the distributed computing. Once you look into a security chapter of the distributed computing, it is going to fulfill all your requirement. You'll get all the answers, and indirectly you'll be finding we are trying to say same thing when we talk of the resources. The security issues. Okay, so this is a typical application which I talked. We have different devices. I said we are creating a subnetwork. You know how subnetwork is created for a technocrat. You know network mask and others. So creating a subnetwork, and then this explains. You suppose you have different houses are there, then in apartment, and each you can say is a subnetwork. Okay, each is a subnetwork. What we try to do, all the fire controller you want to form one network. Every house has a fire controller device or a smoke detector device. You try to treat them as one network. So that is subnetwork one. Then again you have got a weather monitoring units or some other heating system. So group of those devices are coming into another subnetwork, right? And this, then you need a device manager which is responsible for acquiring data, or more or less you can say this device manager and the home gateway, it can be club up. into one device and acts as a gateway. Now, interestingly, that gateway is also supports virtualization. Tomorrow, now there are 3 applications. So 3 virtual VMs are created on the top of that, and they are going to acquire the data and deliver the decision, switch up this thing, switch on whatever the decision comes. Now, today you are decided to deploy one more application. Maybe one more VM is to be created on the top of the gateway, and it is going to serve. What is the constraint? Maybe you are finding the resources available with gateway are not sufficient. I mean, in terms of the main memory or the processor core are not available to you because all the computing is dedicated to 3 applications. So that's why when looking into the application, so one has to decide the gateway. And if your gateway is not scalable, I mean, not scalable means you can cascade 2 gateway and logically for 1 gateway so that resources will be more. And some company offers, okay, this gateway cannot be expanded, I mean, scalable. You cannot cloud 2 gateway into 1 device. And then it's up to you. If you are deciding with a low budget, you can continue with that. If you are looking for a new application, maybe you are buying another gateway, and those 4th application will go to that. Okay, so these are the some constants while deciding on the gateway to supporting the IoT application. Okay, now here I have discussed 3 examples of a typical IoT application. Let us say there are few applications are like this: lighting controller, temperature controller, smoke detector, motion server. So these are the few applications you want to deploy, and those applications, as I say, runs on a particular LAN because my whole apartment or the building is a LAN. You may require different gateway so that you are accessing to a particular edge server to take a decision on your temperature controller, or maybe the smoke detector is connected to the gateway available with the fire department, and you can take action. So there are many possibilities are there. If we try to see here, you see there are on the left hand side there are 3 blocks are there which represent 3 different applications. Okay, 3 different applications, and there are sequence of steps which is to be executed are discussed in the application. One key things to be noted, if you look into those things, action 1, maybe looking into the first one, action 3, then action 2, or 6, or 1, and action 3 has to be performed if you complete the action 2. Okay, so these actions, that is whatever the functions I am executing or actions I am performing for a particular application are in a order. And if you look into this, when we model a particular IoT application, this gives us a graph. Okay, or sometimes we call it as a DAG. Okay, direct acyclic graph. A particular IoT application can be modeled as a direct acyclic graph. Okay, then when we look into application deployment, resource, application management, resource allocation, or scalability, so we take the input as a DAG. I mean, I am going to map the DAG to particular resources because I want, if you look into the first example, you see the task 3 required 1 resource, but when after the task 3 is completed, you see 2, 1, 6, all are parallel tasks. So if you have more number of virtual machines or the resources at your hug layer, then 2, 1, 6 can execute simultaneously because 6 gives an independent decision, 1 gives an independent decision, and 3 gives an independent decision. So there are 3 decisions are coming, 3 results are coming as 6, 1. Okay, so just to remember, for IoT application, we can model this as a DAG, and so to facilitate that DAG for execution, the resource which is required must be allocated or a provision should be there at the hug layer. Okay, so I try to put the details into that because I'll be sharing these slides with you. So this just says the typical steps. Again, I repeat, this is just to give you the idea that we can, for any typical application, we can construct a DAG, but that is not ultimate. Maybe I am assuming the DAG model for application is to be represented. Maybe you can find there are other models through which this application can be represented. Okay. So I'll just these are the examples. So you can see how the DACs are correlated. So there are few points when we can say the fog computing is to be used. So it is used only when the selected data is required to send to the cloud. Selected data, not all the data. So this selected data is chosen for a long-term storage and less frequently accessed by the host. That's why the cloud layer is there in the backend. Okay, so it is used whenever the large number of services need to be provided over a large area at a different geographical location, maybe a smart city application. So devices that are subjected to the rigorous computation and processing must use for computing. Okay, the devices are available and it is fully utilized with the computing. A real world example for computing uses IoT devices. You can look into the car-to-car consortium. Nowadays, people are looking for this driverless car, which is actually truly will be application of the this edge computing or fog computing, and they try to utilize these roadside units. Mostly these internet service providers, they are having the towers and others. Now they are going to equip those towers with computing capability. And in one of the news, AT&T has all his towers in the US now. They are enriching them with computing capabilities so that this driverless car will be a success, because the computing requirement has to meet there itself at the roadside unit, as you say, in vehicular network, or sometimes typically you can say the tower, which is a mobile tower which is available. They don't have the computing capability. They have the machines which looks into certain network functions. So they are expanding the resources there, and they are going to be act as a fog node. They are going to act as a fog resources. Okay, so I can skip this thing. So now let me talk about the fog node. So fog node is the heart of the fog computing. As is a physical device, so it has certain capability, it has certain resources. Now, when I talk about so many functions I have talked so far, so at least you can imagine what are the resources there will be in the fog node. Definitely, the fog node must be capable of supporting virtualization, meeting the computing reads. Sometimes it requires a very high-speed processing. Maybe so one day you'll say, no, my fog node can have a CPU. Answer will be yes. But this is not for a huge volume of data. It has to be actually limited with a less volume of data. So, okay. So, so this fog node, which is a physical device, so these service providers are coming with a devices that is capable of doing so. Otherwise, if you take a typical computing server and try to place it as a fog node and configure it, answer is yes, you can do that, but you cannot get the maximum benefit out of that. Let me tell you, when we talk of a DNS server, I can make any PC or any server as a DNS server. What the DNS server does, you type with a domain name, that will be result to the IP address. If you look into the machine, it can execute one instruction simultaneously. If I type google.com, then it finds the corresponding IP address and then it connects to the server. So even if I use a faster machine, I'm going to execute, I'm going to resolve one request maybe for some millisecond or maybe less than that. Okay, but there are dedicated hardware servers are there where parallelly we can resolve many requests, right? So making my own PC as a DNS server and taking a dedicated hardware which is designed for a DNS server has a different performance issues. That's why the fog node, if somebody say, can I have use my PC as a fog node? Answer is yes. So that is why we look into this last line. So fog node, a computer can be a fog node, a mobile phone can be a fog node, and a smart edge device can be a fog node. A car onboard unit can be a fog node. Maybe the sensors which are there with a little bit of computing capability, they can be fog node. So all these devices which are sensing, they can be also a fog node. Okay, but in the fog layer, we are not going to deploy that. But if you say there are 10 sensors in the car and your onboard units want to ask as a fog node because there is a computer, we are increasing the capability of that onboard unit. Yes, it can be. Okay, and nowadays you'll be finding many applications. Your smartphone has a processor which has computing capability. Now let us say I can give you this example. Suppose there is a tiny software when you capture a particular photograph, and in photograph you want to do the feature extraction, and for feature extraction there is an algorithm has to run. And if your mobile phone has that particular software available with the firmware itself, and the processor is capable of executing, then you are taking 30 frames continuously photograph, you are doing feature extraction and only sending those information to the upper layer, right? The same thing people are trying to do with the cameras. They try to build that camera has a capability which will do the stream computation. So this is a trend try to bring the computation into immediately to the device so that decision making will be faster. Okay, so next is that all physical devices are hub node connected with a different network technology. That is one of the challenge for synchronizing and storing the data, forwarding to the higher layer. So the aggregate and abstract is to be viewed as a single local entity. So that is requires a network virtualization, so that, or you can say logical network to be connected. So this is to be resolved. And that is the hub node able to seamlessly execute the distributed service as it is a single device. We have many nodes, resources combined to in a fug layer, maybe 2 or 3 resources combined treated as the fug node. So logical integration is another category. Okay, so this is look into that. I'll be looking little depth into the fug node. So fug node actually this supports a virtualization. Look into that. If you look into the fug node and the right hand side of the diagram, there are 3 applications are running, and 3 applications requires different library. Okay, one may requires a statistical library, one may requires a mathematical library, you can say. Okay, so application 1, application 2, application 3. Now this we explains this diagram. You may find another word called container engine. Okay, maybe the same thing I can discuss with serverless. You see, your machine device connectivity is wireless with the operating system. Let us say that is dedicated to that particular switch. As you have seen, the diagram looks like a switch and with it to connectivity. And then there we are designing different containers. For different application, we are designing different containers. So we have a software layer container engine which helps us to create the container where 3 applications has to be run. Then you may ask how the VM virtual machines are different. You see, in virtual machine, you need the, if you remember the layers, you need the hypervisor, you need operating system, those layers, because my device is a small device with a less amount of memory. So I cannot put a lot of bulky software into that. Maybe my only operating system and without any container engine capability, I'm going to do. Okay, so here the network virtualization is coming to play the very key role, where we, by and large, we talk of software-defined network, adding the controlling capability, everything, all the functionality has to be done through the software, treating that device as a computer. So the critical responsibility of the fug node, when we are going to design it, receive a real-time data from the IoT device, run IoT-enabled application for real-time analytics, and can typically respond to the request in a millisecond, that is the latency, provide temporary data storage until the necessary data will be uploaded to the cloud or forward to the cloud, send periodic summary to the data collected from the device to the cloud, and deploy the application from the cloud to the devices distributed across the multiple locations. Let us come to the 6. You have certain application and your device has very less memory, but your device is able to know if a particular requirement is there, where to get that software, who will load that software to the VM. I created a virtual machine. My virtual machine will execute certain software. Now the question comes, where that software will come? Let us say I have a very less memory. I can execute Synex only, but I have to first read the Synex into my memory. Or I can simply say, if you know how an interrupt is executed on a machine, a particular interrupt occurs, interrupt vector table, I identify the interrupt, then that interrupt subroutine has to be loaded. Let us say I'm not going to load all the interrupt service routine into my memory. So if I identify this subroutine has to be executed, I have to load that routine to from my disk to memory. So once it will be executed, I am going to serve it. Similarly, if you look into that for a deploy application, that means there are a lot of application or solutions are available in the cloud. If it is going to identify a particular service which is required or a IoT service is required, then edge device has to put a request and they will download those codes from or the routines from the cloud, but execute at their own resources at the edge. Okay, maybe at a single location, maybe at a different location. If a single controller is there, it will find one copy because there is a logical grouping. It will distribute the same software to run on the top of the other. Okay, so this is the something which I refer the Cisco IoT system. So which has a comprehensive set of products, technology catering to the IoT solutions from cloud. So they providing in terms of the English technological stops. So supporting network connectivity, physical management, automation, and application platform. These all issues are addressed with their device and device having capability. This is for you, which I was talking from sometime in the while discussing. This is an industrial integrated service router. You see, this is a router, but it has a capability to support the virtual machine. It has a hypervisor capability built into that so that you can create a virtual machine. And it has a capability that it can directly, in some diagram you'll be finding there is a direct connection from fog to the cloud. I mean, the two things doing simultaneously. There is a fog layer, but this also acts as a directly it can upload to the cloud. While doing all these functions, I mean, this is uploading because intermediately I'm not going to store that. So you'll be finding in some diagram people are showing physically, but physical devices are available. You see, this is a generic architecture of virtualized fog node. That means we are creating a fog node on the top of a gateway or top of a switch or top of a router. And so these are the shows the different stages, how the data are coming and how it is goes to from processing and again it will upload to the cloud. Okay, so all these things takes place as a software module. My switch is software, load dispatcher is software. So some just to in the nutshell you can say there are some functionality. But how I view it or how you can view it when you want to do some nobility work, you are finding, let us say, there are 10 functions which is described here so that a fog node can be virtualized. That means my virtual fog node is capable of performing 10 functions. Now you are trying to doing a application, you thought or you propose there are 2 new functions is required and you justifying that those 2 new functions has to be added. So you can modify a diagram, put those 2 new functions, show the connectivity why you need it, so that will lead to innovation. That will lead to new things. Okay, these 2 things are required. Maybe somebody can question whether this is secure. Okay, maybe he's finding that there is a lot of security lapse into this. So he proposes some security lapse into security patches or security module to this particular diagram. Then you say my proposed architecture or proposed module is used to design a secure virtualized node. Secure virtualized node. Okay, so now when it comes to the container-based virtualization, which I was discussing, I'll not look into that. You see the container, we are adding those functions and resources as a bundle and provide that application to be executed. In serverless, we are only talking of function without knowing the resource. In container, the functions as well as resource, we bundle it and put that into use for a particular application. Okay, so if you look into a container, this says your application library, whatever the things are required for an application is available. In addition to that, we are allocating the resource. Okay, so this is also being used. Container is also predicted, or the demands are also predicted. So one can look into both the things for IoT containerization of different IoT application or serverless for different IoT application. Okay, so so this is another issues. Maybe you are running a particular fog services or fog. I mean, you are in fog layer. For those services, you may require multiple clouds, which we talk about the hybrid cloud, because certain security services coming from one cloud, certain analytic services coming from one cloud, and certain clouds where it is only storage cloud which is cheaper. So you need to integrate those three clouds, because you have to optimize your resources or optimize your budget. So this is one of the concept of a hybrid cloud model, where you take the best of the cloud 1, best of the cloud 2, and best of the cloud 3, and you are going to provide a service for your work layer. This is one of the opportunity you can say one can discuss, that how best I can select a mix of the cloud service provider. So this is natural, because if you see, if you are going to address these issues, this is a concept which is coming from your hybrid cloud. Okay, sorry. So, or sometimes we call them cloud concept. Just looking the virtualization for the concept called, and network virtualization, available devices, so, or a network device. Let me tell you very in a software defined in the traditional switch, we have that means mechanisms are being through decision is to be taken by. Okay. So now when the decision making softwares are built into the switch, if sometimes I try to, suppose I designed a best routing algorithm, so I cannot deploy it on that switch. Or time to time, as I have described, the policy changes, and it is moving from one policy to the others. Maybe you are suggesting in the morning I'll work with one policy, and afternoon I'll work with other policy, and maybe after a few days you come up with a new policy. We cannot put them into a conventional switch. So with a virtualization, what happens? The physical deployment of the routing decision, which is required a dedicated hardware or a switch infra, is one, and decision is being taken by a typical server where the program has to be executed. Or you just imagine it's a simple two algorithms are there, and you are developing a new algorithm again, and you can run on a particular machine, and the output you are giving to the particular switch fabric which decides the routing. Okay. So now, why these things are coming to discussion with the IoT? So as the system is installed, and maybe day by day you are observing the trends, maybe users are expanding, maybe certain new data volumes are increasing. So we are not sure what type of policy will be best. Maybe you have to change your policy based on your scale of your application, maybe requirement, resource requirement changes. So in those cases, you need that you must have flexibility that a new algorithm can be deployed. So that is answered by your network virtualization, or in a particular HDL capability of the switch. Okay, so that is the reason you look into this middle layer, where core network neural switches, MLA monitoring traffic. So controller is one machine where the algorithms are run and decisions are given to the switch, and they act according to that. So that is provides the flexibility, or you can say the scalability, or you can meet the heterogeneity. Various issues can be addressed. Maybe there is a very high data rate through which a IoT device try to communicate, and that data requires a different type of function, or another device which is periodically going to connect the data. So those type of algorithmic decision, if you change your policy, you need a software routine has to do that. So that is also going to affect. Keeping your IoT application fabric constant, if you try to improvise, you are talking of a quality of service, or you are talking of SLA requirement, one may look into this functionality. Can I modify that so that I can meet? Instead of the other policies or the best algorithms what I am using in the edge layer. Because certain data, as I say, has to for storage or maybe backend analytics. And if you try to bring those things next level, to the fug node also. Same thing, virtualization for that. Okay. So this is a typical looks like without fug node or with mostly try to say the latency. So in the fug, if you look into that, the receive feeds the IoT device using any protocol in real time. So that protocol management is one of the key. And second, so the storage which is there, which is has to summarize and or compress or to refresh to the cloud, clean the storage and acquire the more data. So these are the few challenges when you look into the fog node. Okay. So difference between this fog, the cloud and the edge. As we edge, we take into that as I have defined, it's from IBM. So you can compare the different features and you can find many years with the fog, and we are not going to use the multi-energy saving the applications to do that. So only we compare the edge, we have the advantage over others. Now we'll talk a little bit about this diagram. You see, starting from the data center to multi-edge service, from the fog to the embedded system or the lower devices, always you are finding one word, that is VM. Look into that. So endpoint application, there also we are doing virtualization. A single machine in one application server, one database server. Okay. Next, if you come to the fog layer, different layer wise, I am creating a virtualization. That's why I try to say the virtualization is the key. Different type of virtualization has to come to the discussion so that we can find out a different solution for IoT application on the top of AS. So virtualization in the cloud, I'm not going to discuss. Only just to remember, actually, this I told that when we come a bare machine, we need a software that to act as a virtualization which runs on the top of that. But nowadays, this type 1 hypervisor is popular. So where in the top of hardware, you do not require operating system, hypervisor is built into that so that directly you can deploy it on the operating system. These things are prominent in case of the gateway, switches and others. And the type 2 hypervisor was the concept which earlier used with conventional machine. Nowadays also people are using when they try to create the virtual machine for using their desktop and others. But the type 1 hypervisor is the part of the switches, gateway or devices. So while selecting a devices, one can easily check whether it supports the virtualization, whether the hypervisor, which hypervisor is inbuilt into that, and what are the capabilities. Okay. This is in the nutshell, we talk of 7 virtualization. Okay. Every virtualization is also going to impact the fog enabled applications. This is just for information, I am not discussing. Now let us come to, maybe let me check my time. Okay. Maybe we are talking of when it comes to the resource management and the fog computing in general, we are interested in the application management. So when we look into the research challenges, as you have seen in the diagram, we look into the resources what are available with the fog computing infrastructure. So the first 2 modules, the resource estimation, resource recovery, they are being differently. Resource estimation is that prior to deployment or deciding the infrastructure for a fog computing environment, let us for a smart city, or let us maybe for a chain of maybe a large hospital, how you estimate the resources, it comes under that. So resource discovery, sometimes it's a broker application, some resources are idle and how you can acquire them. But mostly when you look into the application, these 6 are the dominating factors, that is application placement, resource scheduling, resource uploading, resource allocation, load balancing, and resource provisioning. So most of the research work which is going on mostly in the algorithmic, people try to simulate the algorithm and others, is moves around this 6 category: application placement and resource scheduling. I just thought from the very beginning, it looks like very much similar to we are doing with a conventional operating system. Now you see, when we come up the application placement, so I am concerned with the name like this, application placement manager, right? If we look into the fog node, one more node or a software module or a server is required which is going to perform these management, application management operation. different IoT application there. That results a group of applications to be generated. Maybe somebody has got a different requirement like timing requirement and other constants. So you need a manager. Now the question is that what are the functionality? Who will design that controller or the manager? Who is going to do that? What are the functions with it? That's why I told I need a object-oriented concept or a concept one should understood, one can design. Now, let us say one manager is not enough. I need many managers. How am I going to do that? If I'm creating a class of a manager, so if I found that I need 2 managers, I need 3 managers, so I can inherit, I can clone those things. Very simple object-oriented concept. So 3 manager is there. Now I don't require service for 3 manager. Demands are less from the IoT devices. I can collapse them and design one manager. Okay. Now this is application. Then similarly, resource scheduling. These are the computing resources, and up to application we divided into number of tasks, and sometimes some specific tasks are to be executed on a specific device. So we need a scheduler. Maybe you can think we need 2 scheduler. One scheduler is a function with a control node or the master node or the gateway which does that. Then you need a local scheduler, as you have seen. Each computing device or the fog region or the fog node. So things are queue in front of them. So they are going to do that. Okay, this is a 2-step process of resource scheduling. Then task uploading. You see, task uploading sometimes we call about this migration and others. You see, there are the different resources. You see, everywhere is appearing VMBA. Now it becomes virtualization. We are not exactly using the term fog gateway. So you have the fog gateway. You see, what is the capability we are adding to the fog gateway? Fog gateway is going to take a decision, uploading to one, uploading to others, how the migration has to be takes place. So look into this orange color block. So if you say a fog controller or a manager, so it has the capability that can take a decision. So each is again a research area, I will say. Each again a research area. So this is our task uploading. Again, if you look into that, then comes a load balancing. Load balancing actually comes into 2 terms. One is comes as a load balancer, which is a hardware device connected to the server. And here, as we don't have any dedicated hardware devices, we need a software or a virtual machine which will act as a load balancer, to which the traffics or the requests of different IoT devices are coming, so that it tries to evenly load the fog computing resources. Okay, maybe with a different objective, maybe with a max span, maybe with consuming less energy, that will be the choice. Next, next is the resource allocation. And these fog computing resources, again, we need a resource manager. Now, if you look into all these functionalities, 6 functionality, it can be clubbed up with one entity which is performing that. If it's overburdened with that, when IoT devices are scaling, you need more manager to do that. That means we are talking of a manager which has the different capability to do all this functionality. A single person can do resource allocation, load balancing, etc. If it is not sufficient for one manager, we need many managers or many controllers. Okay. Now there is a resource provision. So we have different type of resource. Some are storage, some are memory, some are bandwidth. Bandwidth is a very good example. If we continuously query is landing to your database server and to application server, and application server has to pull the data from a database server. So I need a bit of thick pipe. I need a more bandwidth between my application server and database server, so that my response time will be minimum, because I have to put the users are putting the request which comes to application server, goes to the database server, data has to be retrieved and sent back to the application server. So this is the resource provisioning. So in nutshell, we are talking of a particular cloud manager, a fog controller, fog manager, fog gateway, and we can do the virtualization, design a software which is capable of this, taking these decisions. Okay. So, Dr. Srinivas, hello.
Sir. Yes, sir. Yes, sir.
I need just 1 minute break, and then I'll talk a little bit about one of the application placement issues. Can I do that? Maybe what is the time permitted now?
So just a minute, sir. Just a minute, sir. start till 12:30.
Okay, okay. I just need a 5 minutes break and then I'll be back. Huh?
Okay, sir. Okay, sir. No issue. एक
Hello.
हाँ सर
Yeah. Maybe I am I'll spend 10 to 15 minutes on this topic, then I'll try to address the question from the participant.
yes
So,
sir
uh, hello again, we are continuing after this break. Here I put some snaps to some of our published paper to address this issue. And when we try to model the fog layer, this is not the absolute modeling. If you know what are the resources are available there, in general, the fog devices, so you can put finitely many fog devices into the particular layer. So model is your choice, but one thing has to be must. Along with the fog devices, you need a manager or a resource manager, or you can say the particular node is capable of addressing all those 6 functionalities. That is your fog control node. Okay, then how you are going to model a fog node? That is in terms of the virtualization technology, which is going to address in terms of your memory, in terms of a computing capability, maybe in terms of core, storage, and type. So how we can do it? Okay, I'll be quickly coming into that. How the modeling, what are the modeling? When you try to model, how you are going to do that? Actually, this is being secret. The slide is being put at the end, so I have to quickly look into that. In the node cell, when I try to do the mathematical modeling, there are the two group of people. One, when we try to do all those things, we try to take the help of the simulator, and some people are going to design their own simulator. So if you are going to design the own simulator, you can have your mathematical model because you are going to write down the code by yourself. And if you are taking the help of any of the simulators available, and based on the literature, what are the simulators being used by different researchers, so then this resource modeling, what you try to do, first you have to look into the simulator. If simulator defines a fog node with 3 attributes or 4 attributes, then you have to refer that in your model. If you are going to define more attributes which you are not going to reflect there, then it will be a problem, because I define in terms of core, memory, secondary storage, and others. But my simulator, I'm going for a simulator where attributes are less than that. So these are the few simulators which is surveyed by my group. So showing the different simulators and the topology through which they are connected. Topology through which they are connected. Okay, sometimes the topology is also questionable because a typical network topology, whether it can be a graph or it will be just like a typical network topology like star plus bus hybridization. So that is then based on the selection of the simulator, then it will be appropriate if you are going to model it. Okay. So when it comes to the functionality or the problem, then you have to, and those problems are again fall into a particular category. Starting with simply with because the objective, let me tell you, the objective is to look into, let us say, for a resource allocation, we are looking into a best policy. And as I have explained, that policy will be part of the functionality of the master node or the controller. Okay, so that means initially I have to characterize or I have to model the fog layer as there are two entities are involved. Sometimes something has to go to the cloud, so I need to model my fog layer as well as my cloud layer. So that I have one constant. Again, I told and to repeat, I can model it. I can go for a mathematical model, which I can propose, or I can go for a new model for which I am going to write the code and do the simulation to establish my claim. Or if I am going to finally do it with a simulator, then it will be a reverse array. Say you have to look into the simulator first. What are the attributes they permits, and you follow that mathematical model. So it's not like that you are following a particular paper, people suggest a model and you are going to do that. Because sometimes there is a gap. Mathematical model is defined, some simulation is made. If a simple question is asked, do you implement this algorithm on that? So there is no scope, it's a black box. I mean, people will show some formula as latency, but that is not possible to implement in the simulator. So there are two choices. If you are designing of your own simulator, propose a mathematical model, write down your own code to do that, or you try to take the simulator, then you present a mathematical model of the cloud layer and as well as this layer. Okay. Now, as I say, this is software architecture or different functionalities are involved. These decisions which you are going to finalize will be available as a function. When we are going to characterize the IoT application, so now we did the IoT application as a software as a service. So I told from the beginning, if you are going to take the software as a service from the cloud service provider, the whole things you are taking, you don't have to do anything. Because it is designed, you are taking a service which is already designed for a specific application. Let us give me a small example. Let us say biometric attendance. Biometric attendance, if I am buying from a company, I am buying the recognizing software, analytic, everything. So I deployed on the server. So this is a software as a service. But when we are coming into, when the applications are heterogeneous and we are trying to look into different applications, then we have to design those two layers, data and application. If you remember the platform, infrastructure, platform and software that has to be designed. Okay. So this thing I told from the beginning, the hard deadline, soft deadline and no deadline. Mostly we try to do it for soft deadline. Hard deadline requires a different type of OS service and hardware, because the hard deadline, the time has to be predicted exactly. So nowadays with the virtualization, we can run a real-time OS on the top of a device and we meet the hard deadline. Okay. So this is what I was insisting. Suppose let us look into a typical IoT application. You'll be finding the two entities must. Your fog node is there, cloud node is there. You need to draw a sequence diagram how the data is moving from one entity to one stage to others. And these stages, you look into that. IoT device, IoT gateway, broker or the manager, or you can say fog controller, then fog node, then cloud data center. What I try to say, when we model the system, if I'm drawing a hierarchical diagram, then my hierarchical diagram should include these things. I'm showing a system model and drawing a different sequence diagram. No. If you show three things on your system diagram, maybe cloud on the top, fog on the in between, and IoT device at the end, then you may delete this IoT gateway and others. But then the decision has to be given. The decision has to be given. So that is must. After computation, you have to give a decision. So decision means you have it. Again, now when you look into the diagram in the downline and coming from top to bottom, maybe you can say this is the time, the latency, and there are some activity where latency cannot be reduced, and there are certain scope the latency has to be reduced. So that has to be defined. So sequence diagram is one of the best way to do that in terms of the functionality, in terms of designing. Now IoT application modeling, I have said there are multiple tasks has to be carried out, and these tasks, if it can be mapped to a specific functions, then we can have a serverless. Suppose I have a different function. Maybe a few functions are repeated. I can map my DAG into a serverless. Okay, I can map my DAG to container with function requirement plus the resource requirement. So DAG is the key to that. If you survey on the DAG, then if you class up IoT application, we categorize into monolithic applications. Suppose you want to do the simulation, you need different type of DAGs. So there is a class of DAGs are available. So application has to be modeled, and application DAG has to be modeled. And when it requires a computing requirement for that, then the computing capability or the processor capability has to be designated with MIBs, and so that we will be able to formulate a objective function. As I have said, we have different type of tasks. There may be independent tasks, there may be different tasks are coming. The dependency is there. Then it is ultimately, you can say, a DAG scheduling type of thing, and with a certain constraints. And sometimes we have the task where it is IO intensive, we are only acquiring a data, very, very less processing. Maybe sometimes memory intensive task, so that has to be designated. What's the best way of doing that? Maybe you are making a provisioning of fog resources based on the tags. You will just group the fog resources. That means one group which you are finding logically a group is for. Let us say you have more IO intensive tasks. You put them in, allocate them adequate resource and form a group. And then your manager is going to take care of that. And your fog controller is capable of doing that, grouping the resources available at the fog layer, depending on the application type or depending on the deadline type. So that is another capability which is to be coming to the fog manager. Okay, so this is a application quadrant, and when you, in general, it's a we have taken from the paper. So based on that, you can designate which is more system oriented and person oriented, and where the scalability is there, where the data volume is high. You look into the axis, multimedia content is moving upward and scalar content is moving downward. So these are the different way you can classify your application so that the resource provisioning you can make. And so these are to be a task is to be carried out by your fog controller. Okay, so then if you want to do the simulation with a different type of DAG, we have different type of DAG like pipeline task graph, star task graph, isolated task graph. One can take high and alpha array task graph. These are the models one can take and design a backup task mix, and you can do the simulation on that. If you are, I'm talking of when you are going to design your own simulator. Okay. So the performance metric which is to be considered, the average response time, packet loss ratio, success rate, reliability. So depending on your objective function, this thing has to be defined mathematically how you are going to measure. Then only you are in a position to design your own simulator. And if you are going for a simulator, I think then it's a black box for you, and whatever the facility is there, you are going to use it. So I'll be just talking of the application placement. I'll take only 2 minutes. When we try to place a application, we assume that the application is consists of set of finite number of tasks, and as we have finite number of nodes, we model this problem as a NP class problem, because you see the application case goes to any fog node, my application has got 10 tasks. I may need 1 fug node, 2 fug node, 3 fug node, 4 fug node. Suppose I have got n fug nodes. So number of combinations possible or number of subset that can be formed out of n members, that is very much simple as a power set 2 to the power of n. So I need to find out of the 2 to the power n numbers. So my application has to select how many. Maybe only 1 fug node is sufficient, maybe node 1, node 2 will be sufficient, maybe node 3, node 4 will be sufficient, maybe node 1, 5, 6 will be sufficient. So I'm talking of all power combinations because I have a constraint that is to meet the deadline. So it's a complete problem. So we are looking into the size that. Then we did certain proof to prove that this application placement is an NP class problem. And after proving this application placement problem, we are going to find out the solution. So this is again a simplified diagram which I told. IoT device, fug node, fug controller, and cloud data center. And again I say here, if you see the red blocks, what I try to do, you are sending a application. I could have drawn the arrow in a tilted fashion and this red block is showing the latency. And how I am going to do that? If there are many red blocks are there, few red blocks which I cannot do because of the communication and device constraint, because the data rate transformation and others. Few blocks, if I can reduce, if you totally looking into that from IoT devices to fug node, then the decision of the response sent back to the devices. If I want that is to be completed before a deadline, then I have to look into that which blocks I can reduce. Which blocks reduced through a software management. As I say, few blocks time we cannot reduce because there is a hardware constraint. If my channel is fixed, data rate is fixed, protocol I am using a certain type of protocol. So I can't manipulate that one. So this is the best way to, if you are working with a constraint and meet a deadline. So then the system model for application placement model is important, and the entity involved in the system diagram has to be considered so that you can formulate mathematically the problems. Okay. So there are few drops from our publication, my group. You see what we try to do. We take a particular Cisco gateway model and try to take the characteristic available with that particular gateway, and maybe you can take that gateway, and if you are finding like IFOXSIM or others which is supporting some physical characteristic, you can put those characteristics there in the simulator. So that will be a good if you mention in your work that I have followed this particular gateway and I have taken the characteristic from that and try to run in the simulator. So, okay, this is from my side. I'm not, this is a taste of the time, and I love to share the details if anybody required any personal assistance on these areas. And now, Professor Srinivas, I am ready to answer the question if any questions are coming from the participants.
Yes, sir. Some of the questions we received from the different participants. So the YouTube, okay. I post also. So if any question will be arise, then maybe pass through this chat box so that you can see the message, and also you can also see the message and for the discussion. Now, thing is that, sir, from the different YouTube people are in our group asking about the security application in this architecture.
Okay. You see, in general, if you come to the security, first is that the question is that the mostly the security here is only because of the network. There is no security issue as such different what I feel. When I'm communicating, my IO device is communicating to the next layer. So I am using a network protocol, right? If I'm using a wireless protocol, let us say 802.11a, 11b, 11n something. So that protocol has already specified what are the threads in each layer. I mean, I'm talking of a 5-layer model. So each layer thread has been specified. Now, you see, when a protocol is standardized and there are certain algorithms that are certain things taken care of by that protocol. We are from our side, we cannot say that this is a threat. If you look into that, if I say denial of service attack, you'll be finding, where you'll find, I'll tell you, you go for the RFC because standard documents are locked by IEEE. You go for the RFC. In the RFC stands for resource for comment, which is prior to approval of the standard, it is released. And original standards sometimes available, and most of it is available with IEEE. Sometimes they open up. So there you'll be finding what type of threats it is there. It is nothing to do with IoT devices in particular. It is with the network. And if what I try to say, knowingly, unknowingly, we talk of a network security threats, which is already taken care of by that protocol. That has to be seen. If I say, no, I am working on denial of service attack, you are using a protocol, but that has been already taken care of by denial of service attack, how it is to be managed. So it is not a challenge, right? So that has to be seen first. Then if it says, okay, there is a protocol and which is not going to do that. Let me give you a simple example I always give. There are people are talking of AODB, that they design some protocol and compare with AODB. But they forget that the secure AODB is already there. If you need to compare, you have to compare your protocol with secure AODB. But first is the threat model. You have to tell specifically you are talking of which layer. First layer, you're starting from physical layer, threat model is fixed. Then after fixing the layer issue, then you look into the security challenges. Second, you need to prove that if it is going to be affected your system. Suppose there are certain threats, but it is nothing to related to my system. Then why should I address that issue? Okay, you have to prove that because of this security threats, maybe I'm not able to meet my latency, maybe the resources are not available, then you try to propose a security protocol. And moreover, when you try to run a security protocol, if you look into this IoT, again, you have to run that protocol on a dedicated virtual machine with adequate resource. So otherwise, if you run on the same resources, it will consume more time and latency is going to be affected. Okay, very simple thing. If a computation, if you want to use a encryption algorithm, that will add the latency into the overall performance. Okay, that is to be addressed.
Okay, sir. Professor Sanjay, Professor Vinay Patra asking that just a minute, sir. How it is helped to analyze the time critical data like device status fault alert.
Fault alert. You see, yeah. Fault. You see, then again I say which type of fault. When a device starts, any devices it has a capability called built-in self-test. So there are certain faults which the device starts with diagnosis through the built-in fault test routine. Fault and security and deadlock, they are very similar things. Again, the fault has to be defined. Which type of fault you are going to do that? There are certain faults which we cannot address. And there are certain faults which we can address like this. Let us say, logically, I provide you 4 IP address of the machine where your task is to be executed. You need 4 machines to execute your task. You need 4 virtual machines to execute your task. You do not know which machine. Now, one machine is not available. Who will detect? The fog manager will detect one machine is not available, right? So what I can do? I will take another machine. I will replace the IP address of that machine with the machine which is faulty, because your algorithm is mapped to 4 destinations only in terms of address. That's all. It is going to solve the problem. And there are some traditional backup, fault tolerant algorithms are there, like KDF and others. Typically, it goes to the real-time system fault tolerant algorithm. There's nothing novelty on that. So detect and fault is, as I say, very much similar to your deadlock. First, you have to detect. How you will detect the fault, right? There are various mechanisms. Okay. The simplest mechanism is built-in self-test. Okay, hardware. Then comes the others.
Then Professor Sudhanshu Patra asking that task offloading is done when and is which layer? How secure doing task offloading?
Task uploading is the basic function of your controller, because he is the resource manager of the fog resources is available. Because you see, when we look into the fog layer, the total fog layer is protected by your firewall. There is no unauthorized user entering to your fog layer. Now just think of in a data center like that, you are with a DMZ zone. There are two firewalls are there. One is connecting to the cloud layer, other is connecting to the user layer. So we don't have any threat that any intruder enter, and we can. So there is only resource allocation. Security threats are not there when it comes to uploading, because you decided I'll load into 4 nodes, so I'll upload. Because I could not show you the architecture of the data center or like that. Just imagine this fog layer has in a DMZ zone, demilitarized zone. There are 2 firewalls there. One firewall through user is connected, that means IO device is connected. Another firewall through which you are connected to the cloud.
Okay, sir. Then Professor Raju Bhoyar asking that, is IoT application for PV system?
PV, can you elaborate? I am not immediately recalling.
Hello. IoT, is IoT applicable for PV system? Hello.
PV, can you elaborate? What is PV? I am not getting immediately. I cannot recall.
I request Professor Raju.
PV actually, what is the abbreviation? What exactly? So that I can clarify. You can type in the chat board. Professor Raju, you can type in the chat board.
Hello. Okay, sir. Okay, sir. In the meantime, we'll discuss some couple of minutes. Sir, I think that if it is applicable for the security purpose, and is it better for the blockchain application or blockchain
Yes,
application
blockchain.
for the
Yes, blockchain I can address. You see, typically blockchain application, once it is a distributed system, first it is a candidate for blockchain. First thing, the system is a distributed system, then it is a candidate for the blockchain. Now, if we are sending, as you see, we are acquiring the data, we are sending for one application or one service. Let us say some pre-processing has been done. Again, it's sent to the next layer. Again, it to send to next node for. So yes, we can apply the blockchain there because you are collecting certain health data. Okay, then you are sending to some processing to the fun node. There you ensure that certain things which is not being tampered or it is being genuinely processed, some information is added. Then it is forwarded to another node for another application. Yes, blockchain can be very much applicable because here we have distributed resources, distributed entities are involved. So blockchain is the ideal candidate to ensure the integrity and safety of the IoT application, distributed IoT application.
Okay, sir. Thank you very much.
Sorry,
I hope
it is a PV system. It is a photovoltaic system, sir.
Okay. PV system is photovoltaic because you see, finally what photovoltaic you are acquiring certain energy or the data. I mean, you want to treat each and every photovoltaic system or solar cells as one of the IoT devices.
Yeah.
So you have a chain of devices which is connected. What information, what control function they require? What control function they require? That means you don't want to take the
solar irradiation, temperature, and then atmospheric conditions. Just
yes, sir, it is there, but
that is a fog conditions.
Okay. If what I understood, if your solar panel is fitted with a stripper motor, if the direction of the sun and other changes, depending on that, if a rotation has to be made, then it is yes, it is possible because you are getting the data. Maybe intensity of the sun is changing, then you need to rotate that motor by a certain angle. Yes, then it is fine. Then because we need a certain decision to be delivered and that has to be carried out through the actuator. Yes, then it is the ideal candidate. You are continuously. Maybe you can talk of monitoring a data center to reduce the power. That type of things you can do. because you are getting some data, some decision has to be taken. Okay.
Okay. Okay. Thank you, sir.
Thank you very much, sir. I hope it is help a lot for the researchers and the different in a one platform. People are getting different information like IoT, fog, and your SDNs, and so many things like your security in the IoT, security in the SDN also, and blockchain concept. So I hope it will help a lot for the researchers. Okay, thank you very much, sir. Thank you.
Thank you, Professor. Thank you, all the participants. It's a liberty. And I thankful for your patience and
So,
cooperation from all the participants. Okay, thank you all. Thank
so,
you.
so I request all the
Thank you, sir.
participants to rejoin.
Professor
That is
Srinivas, can I do?
by two, sir.
Can
Yes,
I
sir. Yes,
do?
sir.
Okay, thank you. Thank you.
Yes, sir. Thank you very much, sir. Thank you for your valuable suggestion, sir. Sir, I request all the participants to rejoin the systems by 2 p.m. so that next session will be start in times. Okay. Thank you for your patience and nice cooperation from the different members. Thank you very much. Once again, meet you by 2 p.m. Okay. Good afternoon, sir. Hello. Hello.
Good afternoon, sir.
Good
Good
afternoon.
afternoon, sir. Hope I'm audible to you, sir.
Yes, sir. Nice voice, sir. Sir, any noise at your end, sir?
No,
No,
not
no,
at
no.
my
Have
end.
you? No, sir. My point is that have you faced any difficulties due to the noise?
No. Actually, little bit of hush sound is coming from your end, I think. Maybe.
Just now, that okay, sir. I will check.
Just kindly confirm, sir, whether my screen is visible to you.
Yeah, everything is okay. Okay. Good afternoon to all of you. Now, Professor Nagendra Kumar Suryadevara joining the meeting, and this session will be discuss about this machine learning for time series data analysis. It is now burning topics in this world, and most of the thing will be helpful for the researcher. He is from this University of Hyderabad. uh, Morning session. In morning session, Professor Udgata already introduced the regarding the Professor Nagendra. Uh, so it is not requires. Only I can say that he is a very good researcher and many publications, many attached with many conference during his teaching life. And also he has some project assignment to complete in his during his periods. So I hope keep this kind of this machine learning for data series, data analysis using the time series helpful for these uh, different researcher. Those are carry out the process in his or her life, professional life, research life. Please try to learn about this topic, because nowadays most of the work has been carried out by these machine learning applications. Okay, I hope all of you listen and implement in your life, and you get benefit from this presentation. Thank you, sir. Welcome for presenting the session, sir.
Yeah. Thank you, sir. Thank you for your kind introduction and giving me an opportunity to share my some of the knowledge and the information which I was been working for quite some time.
Sure.
Right. Is my screen visible, sir? Just kindly confirm.
Visible, sir. Visible, sir.
Yeah. Okay. So what
So
about?
that thing is that total it is not. Yes, yes. Just now it's okay.
Sorry, sir.
It
Is
is.
it?
It is now okay. Okay, sir. It is now
Right.
okay.
Okay. Okay. So good afternoon to one and all.
Sir. Sorry, sir. Sorry. Sometime it is it is not coming the full screen, and sometime it is coming full screen, sir. Any?
I will adjust it, sir. I will adjust from my side. I think just this is an introduction going on. So
Yes, sir. Yes, sir.
yes.
Yes, sir. Yes, sir. No problem.
Okay. So the purpose of this session is to make the audience to understand some of the basic concepts and the principles related to the time series and machine learning concepts. Of course, this is a tutorial session. So basically, the way I am going to deliver you is on the aspects, keeping view of the audience to be on the beginner stage. So if you are expecting something on the research front and where some kind of explorations have been done, then excuse me. So basically, this presentation gives you the basic ideas and some kind of practice sessions and the practice tools which will help you to explore machine learning processes with the help of time series data. So the basic motive of this session is to make the audience, or in other terms, the beginners, to start with applying some of those machine learning and the time series data principles and the concepts into the practical aspects. So if you are new in this particular area, then definitely this will be an advantageous for you to go on with the session. But if you are an expert or a very experienced researcher working on this machine learning for time series data, maybe it looks like very trivial for you, but nevertheless, you can just bear with me and have some patience in listening to some of the latest data sets, which I'll try to do some kind of explorations with the Python tools. Good. So let me proceed. So, all right, so we start with the buzzwords, basically the machine learning and the time series data. I have prepared the contents for this session basically on some of the major aspects on how do we handle the data. So for both the time series and as well as the machine learning concepts, the crucial or the crux is on the data. How do we explore the data? So basically how we need to explore means how do we manage and control the data to make some kind of inferences or make some wise decisions for the data that we have been looking for. So I start with the basic philosophy, or in the sense that the basic journey which usually the data processing has, with the introduction to time series and with some minimal introduction to the machine learning. We move on to understanding about the pre-processing of data. So on both the aspects, for the time series as well as for the machine learning concepts, one of the most important starting step towards the analysis of data for both the philosophies is on the pre-processing of data. And of course, I have prepared some of the practicals, in the sense that with the Python programming, I would like to give some kind of demos to you to understand whatever we were discussing during this presentation, how that can be practically realized and how we can apply it onto the real world data sets. So, of course, it is once we discuss some few topics on pre-processing of data, we move forward to its corresponding demo. And after that, we look on to the time series functionalities, basically on the concepts such as forecasting with certain moving averages and autoregressive models. So once we try to understand these particular topics, then we look into the consideration of the Python libraries for the time series and the machine learning philosophies to be explored practically on the various programming environments. So those libraries which are going to be useful for us. And of course, on the latest side, the last 2-3 years, some techniques, some machine learning techniques, which we call it as silver kites, XGBoost, cats. What are these and all? If you have not heard about it, definitely this will be a plus point. But to understand the silver kite, XGBoost, and the cats, you need to have some kind of preliminary information that I'm going to present it before I go on to those tools and as well as the practice with the help of those techniques. So these are the 2-hour session is been classified in the sense that it has been given with certain things. And what my expectation is that yes, I need to have some kind of interaction. So of course, during the online presentations, I do keep posing some of the queries or questions to you, so that at least some kind of interaction will be there for us. So please remember, this is a tutorial session. When I say tutorial session, means basically practice is going to be involved. If you are going to simultaneously do this practice, yes, well and good. If you have Colab, or if you have installed the Python with the Jupyter notebooks, then keep it ready with your systems. And of course, I can share the code with you and you can do simultaneously. But since some of them who are doing a preliminary practice, or a beginner who is trying to apply or learn the things, may not be able to do the things very quickly. So just you need to appreciate and understand how I'm doing the things, and you can later on you can try to practice it and try to explore more. So let me start with what is a time series. So please remember, time series, of course, a lot of technical definitions do exist at different sources. You can find definitions, but let me just, for a beginner point of view, for a learner who is just starting what is a time series, let me just tell you that it is nothing but a set of data which is depending on the time. So some data which is depending on the time. Obviously, if you look to the latest example in the nowadays, what we are looking is on the COVID data. So all our COVID data, if you are looking to various websites or your newspapers and various other sources on the internet, you see that nowadays you are most likely to see something called as how many new cases are being coming in today, and what is the forecast for tomorrow, or more likelihood where new cases or which region or which country is going to have the worst scenario, and so on and so forth. So obviously that example is nothing but this is the best example for a time series data. So the COVID data itself is a time series data because the number of cases that are coming in our daily manner, which has been depicted in terms of date. So date and of course in terms of the regions or the locations too. So your good example for the time series data is nothing but our COVID data. Basically, it consists of a series of values over a period of time. Now, but how do we handle those data? That's what we need to understand. Suppose if you want to understand what the data is trying to tell us, or what precautions we need to take it in the forthcoming days or forthcoming months. So obviously we need to do some kind of analysis on the data that will give you some kind of insights. So always a data understanding is going to be the most crucial part so that we can take some wise decisions in the later part of our life. So here, whenever you try to explore the data, or we try to do some kind of things with the data, anything that is a managing or controlling or whatever may be, if you are simply seeing and understanding the data in whatever form it is, basically that data journey is more or less looks like we try to import the data onto your electronic device. Please remember, we try to import the data or we try to upload the data, whatever the terms may be. So we try to collect the data. So in other terms, collecting the data, importing the data, uploading the data at different context all means this. So once you try to import or upload or collect the data, and that data is being collected from various sources, and the data is being made available on an electronic device, most likely we do process the data on an electronic device. So once the data has been collected or imported or uploaded on an electronic device like a computer or a mobile phone or any resource constrained computing device, which consists of some kind of memory and processing capabilities for us to do some kind of data processing. So once the data has collected from various sources, what we do is basically the first and foremost step will be on the cleaning the data, cleansing the data, or pre-processing the data. So different people will coin this term as cleaning the data or pre-processing the data, or in other terms, cleansing the data with different techniques and different things. See, until unless you don't clean the data, please remember, why? Because the raw data that you collect from various sources will be messy, in the sense that it will consist of unwanted data also, unwanted information. In other terms, some kind of noisy data, which is not in alignment with the data that you're collecting it very regularly. So a lot of information will be irrelevant, redundant. So many, so on and so forth. So here, before we do some kind of processing or analysis on the data, usually we clean the data. Please remember, we pre-process the data. So once we pre-process it, clean or cleansing, or you try to eliminate the some kind of unwanted things, or with the data which is not existing also. Once we do that kind of pre-processing, then the data is moved forward to do some kind of an iterative method. The iteration is basically, iteration is a continuous process here. So we try to visualize the data. Once we clean the data, we try to visualize it, and we try to model the data to depict some kind of strategy, to depict some kind of working nature, and we try to transform it according to whatever the outputs we are trying to expect it. and that visualizations, modeling, and transforming to appropriate target assumptions is a continuous process, and it is a cyclic process. You can call it as a cyclic, you can call it as an iterative process. It is a continuous process, and we try to improve the data there so that we can make some predictions or forecastings or make some wise decisions so that it will be better to our daily life. And of course, once you do some kind of predictions or get some output from that processed data, we try to see it, we try to infer it, we try to make decisions accordingly and do the things properly for us. So in simple terms, the data journey involves uploading or importing the data, then pre-processing it, and have an iterative process of visualizing, modeling, and transforming into the required target decisions that we need to make it, and use that particular decisions in a different way for our day-to-day life. So this is what in a nutshell, the entire big picture of what the data journey is. So here, if you look here, basically the data, what are the data that is consisting with the units of time? So data usually, we have the data which has been collected or uploaded onto a machine usually consists of some kind of units of time. Either it can be a date, or it can be a time, or it can be a week of the day, or it can be a month of the year, or it can be a year, or it can be a decade, and so on and so forth. So usually that analysis which we try to do for the data that is being collected with the help of the time units is basically called as a time series analysis. So here, if you see on the right side of the diagram, you can see the same thing what you have seen in the previous case. You are importing the data, in the terms collecting the data or uploading the data onto an electronic machine, and we try to pre-process the data, which we also call it as data cleaning. And once we process it, we do some kind of internal managements of the data. So here we try to understand the variables. So what the data is all about. So we try to look for the variables in the sense that what attributes data have we collected and what are the features that have been collected here. And so I will be interchangeably using the term features and variables. So please remember variables and features. When you come across the time series analysis, the meaning remains the same. That is variables. Sometimes we can call it as also as a features. Please remember that particular terminology. So once we understand those variables, we try to look for certain correlations among those variables, or we try to understand the internal details about the relationship between the variables or within the variable itself, how the data is looking like. And once we understand that data within the variable or within the feature that we collected and between the variables, we try to look for what is the trend and the seasonalities. So do not worry about the terms called trend and seasonality. I will try to give you some kind of meanings here. Just hold on. So once we identify those trends and seasonalities, again, we may have to do some kind of pre-processing so that a better understanding or a better result is going to be obtained on further tuning of the data that we have collected. So sometimes a pre-processing is also comes into the itinerary. We need to do it repeatedly over a period of time until we get a particular output in accordance to the assumptions that in accordance to the processing that we are looking for. So it is a itinerary, it is a cyclic process. Please remember, it is always a continuous tool. So if you look into the terms like what is meant by trend and what is meant by seasonality and all, just look into the left side diagram. So here the left side diagram, which is basically some kind of a graph which is representing for you, which is basically you collected some sensor data or in other terms some data. It may not be a sensor data, of course, just for you to understand for the basic terms. So some data which has been collected for certain durations, means a certain time, for certain period of time you collected some data. And if you see on the x-axis, it is for the number of days you collected it, and on each day how much duration on that particular object is being used. So in the green color dotted lines indicates the observations. Those observations are basically the durations at which the particular object is being used. So once you have then observations with respect to the date, so you can collect for 70 or some duration of days, 52 days or 52 weeks. It's all up to us to understand how best we can do with the data. So you collected the data and you plotted the graph here. So the green colored dots indicates a kind of durations at which a particular object is being used for a certain number of days. So if you can see clearly, the graph or whatever the observations we have plotted is not linear, in the sense that it is not stationary, of course, and it is not linear. So you can see it's a lot of peaks and a lot of haphazards. It is not in a particular shape also. So it is not very easy to understand what is happening with the data. So obviously the real-time data of the objects usage is more or less, for some of the applications do exist like this. So once we plotted those graph for the observations what we have made or for the data that we have collected, we will try to plot another line. You can see the red color line, which is giving you the trend. So based on the observations, we'll try to get it another term called the trend, what is exactly happening here. So trend gives you some kind of an observation of that. It indicates us more or less to the exactly collected data or to the exact duration at which that particular object is in use. So the trend will give you some kind of insights on the collected data. So how the data is behaving. So the trend will give you some kind of behavior on the observations that we have collected so far. So based on this trend, we can also make use of this trend to make some forecasting also. So we can also do some kind of forecasting. Forecasting means we are trying to it's a kind of prediction here. We try to look into the past data based on the previous data or the past data. We try to give some kind of values so that those values will indicate that more likely the behavior of that particular object's usage can be there in future, in near future, of course, near future, something like this. So we try to get a kind of values. So basically, to understand and to make all these things to be done, so your machine has to understand these behaviors of these observations that you have collected, and you try to you need to mathematically model the observations to make a machine to understand and to make some forecastings and to make some wise decisions accordingly in the near futures. So here, basically, these are all the steps that what actually time series analysis is all about. So time series analysis basically revolves around getting familiar with the data set. So we try to get understanding what is the internal behavior of the data and come up with ideas and some kind of hypotheses which will help us to make some decisions, very wise decisions, of course. So it is a time series analysis is also nothing but a storytelling for data scientists, and it is one of the critical steps in the machine learning. So you need to make the machine to understand the data, then obviously time series analysis will give you some kinds of insights to the machine to understand what the data and how the data is behaving. And obviously, it gives you some kind of tentative conclusions to test while training a machine learning model. So this was a basic understanding about what a time series analysis is. So let us move on to the directly on to the aspects of pre-processing of data. So this pre-processing of data is what we have seen here, nothing but cleaning the data before you try to manage and control the data very wisely. So the pre-processing is going to be the most crucial step. So this pre-processing of data, don't think that only for machine learning philosophies or machine learning algorithms to be built up, we do the pre-processing. No, for any data analysis, initially this pre-processing of data is going to be there. The purpose of this pre-processing of data is to have some kind of curations and screen the data. So you are in the terms that the real world data is messy, it is bound to have it. You cannot assume that you are collecting the data from any device, or you are collecting the data from your for your COVID data also. When you are collecting it, sometimes some numbers which you have been collecting may not be in alignment with the previous numbers you have collected it. So always please remember, real world data is going to be noisy. You can call it as noisy, you can call it as messy, it is not incorrect. So whatever the term use it, basically the data which always will have the, some kind of correct data and as well as some kind of incorrect data. I cannot say wrong data, it is an incorrect data sometimes it is bound to have whenever you could do the data collection and do the data processing. So basically the pre-processing increases the predictiveness of the data features. I remember, please do remember, features means basically your variables. So the pre-processing will increase the predictiveness. So it will give you the more prediction value. Until unless you don't do the pre-processing, and if you don't do the pre-processing correctly, please remember your outputs cannot become correctly. Outputs means you are predicting or forecasting or finding some kind of the behavior, what is exactly going to be happen in the near future. So it is not about happening in the near future, but also you can see how you can make use of that data which has been available in the past or in the near future. So to elevate the quality of your machine learning models, we always require pre-processing of data. So if you want to improve your machine learning models, if you want to make your machine learn properly, if you want to make your machine to do a good job for you, so obviously the first step will be on the pre-processing of data. So pre-processing of data basically includes a set of techniques. So if you see here, these techniques fall into two categories. One is on the feature transforms, another one is called as feature engineering. So basically, these pre-processing techniques, either they are tailored to the assumptions of machine learning algorithms, or they are concerned with conducting more complex features from the existing features. So here, these feature transforms, what you are seeing, feature transforms, basically there can be a scaling, you can also call it as power or log transforms, or you can call it as an imputations. So these feature transforms, these methods, these techniques, basically, these are basically tuned towards, in other terms, they are tailored towards machine learning algorithms. So if you want to prepare a good machine learning algorithms, usually we do some kind of pre-processing by applying the scaling methods and applying the power and log transforms, and of course imputations. Depending on the applications and depending on the data that you collected, we apply different kind of transformations. We apply different kinds of techniques to transform the data from its original form, from its raw form, that is from original form to another form, so that the machine can understand in a better way. And of course, if you want to prepare a new set of features from the existing features, a complex features which you want to understand more in depth, then we call it as, that particular process is called as feature engineering. So actually, why we need to do this pre-processing? So usually, I told you, we need to do this. Basically, the pre-processing is basically make sure that the data is always collected data, or the data that you are going to process, or the machine is going to process it, always have certain kind of information. So here many models or the training processes depend on the assumption that the data is distributed according to the normal distribution. So whenever you collect the data, please remember the data that has been uploaded or collected, it has been assumed. If you want to have a good machine learning model, or if you want to do a good time series analysis, it needs to be following the normal distribution curve, or you can call it as a bell curve. So if you can see here, I think most of you are aware of what is this normal distribution. So basically, normal distribution is the data which you are going to collect is going to come from all different types of categories, or all different types of values. It's not that it is been bound to only certain category of values, or it is not bound to only certain set of values. In other terms, this curve which is giving, which has got the left side and the right side. So a normal distribution is going to exist with respect to your metrics, the standard exploratory data analysis metrics such as mean, median, and mode. So here, the curve should not be skewed, in the sense that it should not be only towards left or only towards right. So if your curve is equally distributed, which is similar in the sense from the left-hand side and the right-hand side, it is symmetric in other terms. With respect to the mean, it is symmetric. Then obviously you say the data that is been collected or it is been given to the machine for processing for further to do some kind of analysis is an appropriate data for doing preparing some machine learning model or making the machine to understand. So in mathematics, this normal distribution term is also called as a Gaussian distribution. Basically, it's a probability distribution that is symmetric about the mean. So we have a data on either sides, and of course, that will give us some kind of equal distributions in simple terms. So even the most widely you are used descriptors such as your arithmetic mean, medians, standard deviations are largely useless if your data set is skewed. Please remember. So until unless your data set is not normally distributed or is not following the Gaussian distribution, if it is not following, even if you find out the mean, medians, modes, your basic statistical metrics will not be of much use to make your machine to understand in a better way. So it's always make sure that data is in the normal distribution form. So if the data is non-normal distribution, it means the data is not following the Gaussian distribution, then we make the data to have certain kind of normal distribution. That is, we transform the data. We transform the data. So there are techniques to transform it. What are those techniques of those transformations? So the scaling methods which are being applied, the scaling is one of those particular techniques. These scaling methods, which are basically involves restricting the range of the feature within two constants. So this scaling is also being called as min-max scaling, is one of those techniques which will make your range of the feature, that's the variable. In other terms, for example, if you're collecting the age of a person, or if you're collecting some manufacturing date of a product. So all this, please remember that manufacturing dates of the products or some kind of applications where the age of the persons are there. So they are being bounded with some values. It cannot be a random number. So those bounding values are there. Age of the person is being bounded with certain value. Similarly, the manufacturing of the product or expiry date of a product is obviously also it has been bounded with certain dates. It cannot go to a very maximum extent. It cannot go beyond 100 or 200 years. So obviously, those kind of values cannot be made transform. So obviously, we need to follow certain scaling. Scaling is you're just transforming the existing values to have certain values, so that it will be helpful for you to have a normal distribution of the data, and further it can enhance your machine learning model. So of course, this is a mathematical equation that you see here. So the min-max involves the restricting the range of the feature within the two constants A and B. So of course, this A and B, you are going to have a minimum value and a maximum value. That's why it is called as a min-max values. And based on this, you can have a certain set of values. Sometimes it can be a special case, A value can be 0 and B value can be 1. This restricts the range of the feature within 0 and 1. You can have those min-max values for your pre-processing feature. We also have another feature transform called as z-score. Basically, z-score normalization is setting the mean of the feature to 0. In the sense that the mean value is been almost to the 0. It implies that, and when the mean value is going to be 0, the variance is going to be 1, basically for the standard set of, in the sense that it is in the ideal case. So basically, this is a unit variance. Basically, it helps us to have the Gaussian distribution. So here, this is another z-score, which also can be useful for us. And looking onto the second transformations, we call it as log and power transformations. So both log and power transformations can compress the values that spread over large magnitudes into a narrow range of output values. So if you have a bigger values, if you have a large set of values and you want to compress them into an appropriate value so that you can have a better understanding of the data, then you can apply your logarithmic function, which we have log of x. It can be binary or it can be a decimal. It's up to your a requirement of the problem which you are trying to address. And of course, you can also use the power transforms, the power value, preserving the original order using the power functions. So here, the log and power transformations can is basically helps us to have certain kind of monotonous values so that it can prepare our data in better form. So under the power transformations, we also have certain kind of methods called box cost transformations, and as well as something called as, of course, this is a single variable or multi-variables, we can have it. These box cost transformations obviously will helpful to have different type of parameters with one parameters or with two parameters, which will help us to have certain kind of applying the optimization techniques and transform the existing feature value into an appropriate form. So obviously that is also going to be useful for us here. So we have like this so many set of different techniques which we have. And if you look to the third feature transform is basically called as imputation. Imputation is nothing but sometimes when you're collecting the data, you may not get the data. It means the data, some intervals of time, there will be some missing values. Some missing values or abnormal values and so on and so forth. So sometimes those missing values, if you want to do the data processing, you can make either unit imputation or model-based imputations. In the sense that unit imputations where missing values are replaced by a constant such as the mean or zero. So usually for Internet of Things applications or for the where you have to do the data processing on a resource constrained computing devices, usually we replace the values if there are missing values or values are not available. You might have seen NAN in most of the data sets. So here those things can be easily replaced with mean value of the existing feature value or with a zero. So basically that type of replacements of missing value, we call it as a unit imputation. And sometimes you can also replace the missing values with certain kind of predictions by applying, of course, another machine learning strategies, and you have a better pre-processed data set so that it can be useful for our data processing. So these are the three techniques. Of course, we'll see the practically, we'll see how do we apply min-max, z-score, and log and power transforms, and of course the imputations. Very shortly, I will show you the demo of this one. And before going to this next topic, then please understand feature engineering is also one type of very good pre-processing technique, basically. So this feature engineering is basically machine learning algorithms can use different representations of the input features. So we can combine those features to have a complex feature which will guide us to prepare a better machine learning model in very simple terms. So new features will definitely can be produced from the existing features in the terms from the existing variables or from the existing data itself. You can prepare a new variable to have certain features which are combined features. Obviously, that will help you to make your machine learning process and time series analysis more robust and more accurate in classifying the things in the later stage. So, and of course, this feature engineering, some people, if the data set is in a less quantity or in a less size, they can do handcrafted process. They can implement this handcrafted in the terms that we look through the data and try to come up with representations that could be useful. You look the data through the data variables or the attributes of the data and prepare accordingly, prepare a new feature or a new variable or a new attribute by combining those existing things. So usually if you look into the time series analysis, we have certain catch-22, which is one particular set, which is a subset of highly comparative time series analysis toolbox, which will help you to prepare these particular new set of features from this existing 22 features. So here, these particular, usually you can distinguish between the handcrafted and automated feature extractions, where we look through the data and come up with this one, whereas researchers and practitioners will take the existing a cache 22, that is what the cache 22 tool set, which will help you to prepare a complex feature from the existing features. But I think some of you might have already seen in the last 2 years, most of the research papers come out with something called rocket technique, or the rocket philosophy. What is this rocket? Is basically is a random convolutional kernel transform. It's an abbreviation for random convolutional kernel transform. It is one of the pre-processing technique, which usually comes under the category of feature engineering. Where feature engineering is, what we do in feature engineering, we take the existing features and make a complex feature so that our data analysis can be more accurate, very in simple terms. So this particular paper, if you might have seen, this is a rocket technique which is exceptionally fast and accurate time series classification using random convolutional kernels. Basically, it is proposed by Angus Dempster, Francois Pezin, Geoffrey Webb in the year 2019, just 2 years back, and which presents a novel methodology for convolving time series data with random kernels that can result in high accuracy and faster training times for machine learning models. So that's what this rocket is. Basically, if you want to understand what this rocket is, I will put forward your understanding in like this. See, you have an image. You can see, I think, in the bottom of the slide, you have the image here. This is the left side of that image, and you can see that there is a different image on the right side. So the right side image is more vivid and it is more clear than the left side image. You can see it clearly. Of course, this image is collected from this Wikimedia. You can just get an information on this. Now see here carefully, the left-hand side image, which is slightly dull, which is the gray color which you are seeing, which is not so intense to look upon. But on the right side of the figure, you can see it's more clarity, more vivid, and you can have more granularity in this particular right side image. But how this image is been transformed from this low resolution image to the high resolution image? In other terms, a very clear image. How did you get that clear image from the existing image? That's what you can see. This particular feature, we call it as the convolutions. So basically, what is the technical term for convolutions? Technical term convolutions is nothing but it is equivalent to transformations. So in our childhood days, you might have seen transformations. You're transforming the data, different types of transformations you might have done on the image processings. So basically, you are scaling your translations, and of course, so on and so forth. Different, of course, in simple terms, you are changing the data in simple way. But how do you change it, and what is the mechanism behind to change the data is what we need to understand here. So here, on the left side of the picture, usually in the image processing, for those people who are not aware of what do you do in image processing, please remember the image is entirely been captured in terms of your matrices. So the matrices will contain your image data, and we apply a kind of filter, or we apply a kind of kernel, in the sense a matrix. So on each pixel of this particular image, we try to apply a matrix. This matrix you see on the left hand side, which is nothing but a shortening kernel. We call it as a kernel. Kernel is nothing but a matrix here. So this kernel is helping each pixel on this left hand side of this image to transform into a better image. So that is what is a kernel. But how do you get this kernel values is what the crux here. So that point I'll get it back to that in the later stage. But please now understand. So this matrix is run on this image, the rectangular image, on each pixels or a set of pixels or a set of matrices, a matrix that is carrying this particular image data. So basically we try to transform that into a better image. So here, that's what this particular technique is. So this is called basically a random convolutional kernel transform. So you are getting a better kernel which will help you to do the image in a better way. That is the output of this image. But this technique is not only for image processing. Please remember this rocket technique. This rocket technique can be applied on your time series data as well as. Basically, this rocket technique can be applied on the vectors and as well as on the matrices. So please remember, you apply these kernels apply those kernels, those matrices, appropriate matrices, not only on images but also to vectors or matrices. So if you look into the basic idea of this rocket technique is it has got two aggregate features. So one feature is basically is on the something called as you call it as a global max pooling, and another technique is called as positive proportion value. So these are the combination of this global max pooling and positive proportion value. This kernel has been brought out, and that kernel is going to run on that particular image. So these two features are created using the well-known methodology. This methodology called as global max pooling. So this pooling is another process. It is basically to select values from the set of values in very simple words. So here, this global means from the available set of values, you select the maximum value. So here, for example, if the result of the convolution is 0, 1, 2, 2, 2, 5, 1, 2, so here the global max pooling returns what is the maximum value from this kernel value. So it is 5. So whereas max pooling with a pool size 3 outputs the maximum within windows of 3. So we get 2, 2 followed by 555. That is what your maximum kernel which has been getting the output from that. So a corresponding matrix value here. So this is what the algorithm is. Of course, I'm not going to give you the algorithm details here. I'm trying to make you to understand first and apply this and learn the algorithm. That is what you need to do it in the later stage if you are very new to this. And also we have this positive proportion value. There's a methodology from the paper is the proportion. Proportion is basically nothing but the percentage of values from the convolution that are positive. So that can be taken a positive value, or based on a certain threshold value, you only consider certain values from that kernel. So on combining these two strategies, that kernel is being prepared and that kernel is going to run on those kernels. So the random kernels, basically each feature of the data set, please remember each feature, each variable gets transformed by random kernels. So the number of which is a parameter to the algorithm. So how many kernels you want to have it? By default, it is 10,000. So 10,000 set of kernels are going to be generated using this rocket technique. So that is by default. Of course, it is. You can change it and you can customize it depending on your data. And the transform features can now be fed as input into any machine learning algorithms. So you can, as an output of these kernels, the transform features can be given to the next layer so that you can improve it further. So this basically the authors have proposed to use these linear algorithms like ridge regression classifier, and with of course with a very few set of examples. But nevertheless, this rocket technique is basically something like a deep convolutional neural networks techniques. Of course, only thing is the intermediate layers do not exist in this rocket technique as compared to the deep convolutional neural networks. Instead of those intermediate layers, this particular technique is going to be useful for our transforming the values into a better outputs here. So that's what the basic idea about this rocket technique. So basically, for those people who know the machine learning, please remember the intermediate layers does not exist as compared to the deep convolutional neural networks. It is equivalent to the rocket technique. Yes, please. Yeah. So now moving on to this rocket technique, which has been just 2 years back only, we got this technique. Each input feature gets transformed separately by 10,000 random kernels. This number can be changed, of course, during the program. But now we have another, this year only, we already come across something called mini rocket. So of course, this is a new variant of this rocket itself, which is more 75 times faster than the rocket technique, and while maintaining roughly the same accuracy. So that's what this is again given by the same authors, and this Dempster. So Dempster is the person who is very much now actively working on this time series data and also so forth. So if you are going to this particular paper, so this, let me just open the paper. Here, the paper is here. So you can see this paper here carefully. Various there in the literature, if you see here, starting with the time series chief, and I'll come back to the abbreviations for you. So if you see here, the least time, that's what the mini rocket which is only very less time it takes to classify the things and more accurately. Is 2.44, and of course the data set is on this UCR problem data sets. So people have run these various algorithms on this same data sets, and they come across this particular strategy. So I have given the link on the presentation slide. You can go through this. So mini rocket, multiple pooling operators and transformation for fast and effective time series classifications. And of course, there is also not only mini, you also have multi rockets. Like this, people have come now, people are working on this time series, which are very fast and which can be easily applied on the resource constrained computing devices. So here, let me come back to this. Yeah, mini rocket. So you have this comparisons which can just get an idea that these algorithms are the latest algorithms which are very much useful for us to use it and explore it further. And we also have another very old algorithm, of course, we are called as TS Chief. Is a time series combination of heterogeneous and integrated embedding forest. So basically, it was again given 2020, and of course, the authors claim that depending on the data set, it can run between 900 times to 46,000 times faster than HiveCote. HiveCote is also a very famous algorithm for the time series. So this, just you can getting an idea here, we will see what is, just to get some more idea here. HiveCote is basically a hierarchical word collective of transformation-based ensembles. Is the current state of the art in terms of classification accuracy. And of course, it is very recently, last year only it has been published. It is a combination of several other algorithms. If you see here, the shapelet transform classifiers, the time series forest, contactable bagging techniques, and as well as random interval spectral ensembles techniques, it is a combination of all these 4 techniques. So here, when you look to the critical difference diagram, I hope people know what is a critical difference diagram. Critical difference diagram, this is a kind of diagram where, if those who don't know, just I'm giving the meaning here, please try to understand. So this is a diagram which gives you an indication about the various algorithms which have been run on the same data sets and looking for the same parameters on the accuracy, the classifications, and other configuration parameters. And of course, they have been compared with respect to each other. So if you look here carefully, the rocket is having the ranking. So the less number is nothing but the better ranking here. So they have been ranking various time series algorithms which have been there in this currently in the market. And if you see the rocket, and of course now rocket has also been mini rocket has come into picture, which is 75 times more faster than the existing. So that's what the authors have claimed. But please remember, these are just very new algorithms, rocket and mini rocket and cats and other things that you are going to see. But still, people have not explored much on various application data. So they have looked only for the UCR data and they have come up with these algorithms. So time series classification, if you go to this particular website, you can see the various algorithms of the time series here. So mostly what are these algorithms, so when they have been invented. If you see from the last, most of the algorithms have come in the last 5 to 7 years. So these are all the algorithms people have come into picture. They have been using, and of course more improvements are also there, but it is not a generalized algorithm. Please remember, it's not a one particular algorithm can serve all your purposes. No. So that particular statement also I can get it back during the practice session. I'll come back to that again. So for those people who are want to explore more, you can also go through these algorithms on this time series classification from these particular websites. So now moving further, we have something called as shapelets. So shapelets are also basically a time series. This is what you call it as, is an algorithm which calculates the information gain of possible candidates and picks the best candidates to create a shapelet dictionary of discriminating subsections. So basically, this idea has come sometime a decade ago, but for some of the applications, even these shapelets are going to be very much useful. So the application of shapelets can be very fast, only depending on the matching of features against the dictionary of shapelets. The performance of these machine learning algorithms on top of shape-based is usually very competitive. Please remember, even if you want to beat something, if you want to come out with new idea, you have to beat these existing techniques. Please do remember that. So of course, I have taken a long time now, almost 15 minutes. So let us do some kind of practice on pre-processing methods that we just discussed here. So let me just open my Colab. So let me come to this Colab. Hope my screen is visible, sir. Can anybody confirm, please?
It's visible, sir.
Yes, sir.
Yes. So here, I will just try to give you some information on the programs here. So try to follow here carefully. So we have a package called Time Series Fresh. Those people who don't know, of course, there's so many packages I'm going to come out in these examples. So here, please try to make an understanding on this one. We have a package called TS Fresh. Of course, most people can know how to use the collabs and the Python libraries and all. So I'm not just going through the Python. And of course, they're not going to the basic libraries like pandas, matplotlibs and all. So I'm just focusing on the time series and machine learning libraries here. Please, I don't want to spend much time on this one. Later, if you want it, I can discuss with you. So we have a package called Time Series Fresh. We have Work Calendar. We have Astral. So we also have featured tools. Please remember, this is what TS Fresh featured tools. If you want to extract the features, if you want to understand the variables, if you want to understand the data, of course, this feature tools is going to be very much useful for you. By looking to these feature tools and the summaries that you obtain after running the programs will be very much, you will get the very much insights and is a clear indication. So let us see here. Of course, I just run the programs one by one, step by step. Okay, now just so I'm just installing the packages. Once your packages have been installed, so you can just have an idea on this one. For those who are new or first time doing, then definitely this gives you some kind of information for you. So basically, all these libraries, each one is quite powerful. Depending on the applications, you can use it accordingly. So it all depends on what exactly you want it. So in this example, pre-processing, I am just trying to make you to understand on the scaling and as well as the power and log transformations. So restart the runtime. Yes, let me just wait it. So once your packages are installed, you can see this step. So please, for the first time users of Collabs and Python, please make sure that you get a right, on the left side, you get a green color tick mark. It means that corresponding statements have been executed. The code has been executed correctly. So I'm moving forward to the next one. I'm trying to import this date times, the pandas, the data framework, and for visualizations of the data, I'm using the matplotlib, and as well as the visualizations of the data, and to have the summary of the statistics, I use this Seaborn. So once I executed it, now I'm trying to do the transformations. So before I apply the transformation, let me just give you a data. So the data which is basically, which is not normal distribution data. So I'm just collecting using the NumPy package. I'm preparing certain numbers, the points, 10,000 points randomly. I'm just picking up the points and I'm plotting them onto a histogram so that I can just get some kind of data which has been collected for me. And later we'll do the transformation and get the normal distribution of the data. So if you see here, the data that is being now collected randomly from this set of points is basically, you can see the histogram, which is not normal. It is not a normal distribution. It is not following the Gaussian distribution curve, basically. So it has been skewed. It has been skewed onto this one. So this is not a normal distribution. Now let us apply the minimax, and of course the standard scalar, the package which gives you the standard scalar, the scaling of the data. Of course, I am using that method also here in this case for you to get an idea over here. So here, once I run the program, so the values are basically the random values. These are values, 10,000 values. So that has been applied to the standard scalar as well as to the min-max scaling method, which has been applied here. So then you are trying to see the significance. So now once it has been applied, so this vals underscore min-max and the scalar, and you are trying to find this val SS. Basically, your the val SS is nothing but which has been fit onto your vals after the scalar of the standard scalar function has been applied here. So if you see the significance is 0, it means it has been transformed from your non-normal to your normal distribution. And you can also use this normal test here, which says the significance is 0 here. So this is basically the standard one which you have applied here. Now you can see this transform. So basically, when the standard scale and the original, the standard scale, it is giving a diagonal set of scattered values, which implies that nothing has been done in this transformation. So now, once you apply it, once you apply the log transformation here, I'm trying to apply the log transformation. Here you can see the log transformation, and of course the significance is you got certain changes. The changed values are there. So you can have the standard deviation is almost equivalent to the 1 here. And of course, the mean is also is almost near to 0 here. The mean, of course, is not exactly 0. It is very near to the 0. And if you plot the graph now here, so usually you can see the graph now. It is basically a normal distribution graph. A bell curve is coming in this particular histogram. It means some non-normal distribution data values are being transformed by applying the scaling methods, the min-max, and of course you can see the other techniques. So we also look for the box cost method here. So I was discussing with you the box cost. So you can see the box cost method which is applied onto your non-normal distribution values, and you're trying to run this one to get a significance. It means that transformations has been done. And we can see once you run this one, again you get this normal distribution from the skewed curve. So again, if you want to apply for the imputation, so here imputation is again missing values. So if you see here, this is what the original array 723, and 4 missing value is there, null value is there 6 and 1059. So from this one, I'm just trying to impute and add the mean value onto this column set of values. So once I do it, I'm getting the transformed values. You can see the missing value here in between 4 and 6, the missing value is 3.5 is coming here. So this is even missing values can also be imputed. So that's what very useful. This is from the package called Simple Imputer package from the scaling process. So you can, like this, you can see a different set of techniques are there. And if you're looking for certain automated feature extractions from the dates as well as from the methods, you can come out with certain things. So I'll just go to the rocket method because of the time constraint. I'm just not going through other time granularity. So let us see the rocket method here. So here this rocket method is very latest one, and you can also import it from the this particular SkyKit utilities. So once you get the rocket from this SkyKit from the time, you can just apply this onto the training values. Oh my God, something went wrong here for me. Okay, let me just check it once. Of course, the dimensions are coming here, the set of values. Okay, because I have not run the data sets. the data set. I have not run it and directly run the particular thing. Of course, you can just get an idea over here. The dimensions, 250 dimensions are there. And finally, you can get the kernels here. So it will take time. You can see at the bottom of the screen, you can see there is a time taken by the rocket function, which has been applied on this a random set of data values, which you can get something like 10,000 number of kernels that you get. Of course, here 1,000 is given. You can go for the 10,000 also. It will take a little bit more time. So kernels are getting computed on that random set of values, and it is being fitted onto this training data sets. So people just try to follow these methods, the rocket and the mini rocket, for your data analysis. This will be very much useful for you. So let me just, it will take a little bit time to compute those values for getting the 1,000 kernels from this minimum value. So I just give 1 minute time for this. And of course, that gives you different set of values. Yes, because it is a little bit error is coming for me. Just excuse for that error. So similarly, you can go for this shapelets, which also going to be very much useful for transforming the data to have a better pre-processed data for our data sets. So I'm just skipping this. I'll give this notebook to you. If you can explore it further based on that, it will be very good. So moving forward, there are other set of let me just go to this. Yeah. Forecasting with ARIMA. Let me just go through the basic steps of how do we apply the Python tools for doing the forecasting process. So let me just directly go to the, yeah. The notebook forecasting here. Of course, I have just run this before so that I will not get some errors. So what this is forecasting is basically a time series analysis. If you want to understand how we need to perform it on the using the Python tools, we got a package called stats model. So here the stats model, and if you want to do the auto-regressive integrated moving average, ARIMA, or any kind of seasonal auto-regressive integrated moving average, ARIMA, or if you want to do some kind of auto correlations, and obviously this particular package is going to be very much useful for us. So you can just install that package and you can explore this. So the data set that is going to be used is basically Yahoo Finance. So here Yahoo Finance is basically you can get the real-time data from this particular model itself. So here I am trying to get the data, the start date from 2005 to 18/12/2021. That is till today. So till today I got the data and stored the data in my data frame here. So morning only I just worked on this particular thing, and of course this is just the previous statements are basically nothing but you are plotting the data in a graphical mode. Those settings are there here. So once you try to, so this is the online opening prices for the Yahoo Finance from this period 2005 to 18/12, that is till today. So this is what you are just plotting with a simple time series graph looks like this for you to get an understanding. So just you can use this particular package, the stats model, and you can just prepare your data sets from starting date to the ending date and put it on a data frame and plot the data onto your matplotlib. So once you plot it, so here the price and the date on the y-axis and the x-axis correspondingly, you can plot the graph. So you can see this is, if you see the data frame, the initial data sets of this one. Sorry. I will not run it again, and because it's already run, you get the it's already you get the data sets here. Now you can see the number of counts in the 52 weeks for that particular year, and if there are any null values are there, is null, you are going to fill up those with your pre-processing methods using the ffill or any other methods here. And you can as well as see the frequency of those particular sets models as well. So you can see this is a partial autocorrelation. So basically it is initially very much high and slowly over the period of different time durations. That basically the lag is nothing but the difference between the current and the previous observations. So you can see that there is a lag here. So depending on as the number of lags are increasing, this particular the R value is getting diminished. So it implies that there is a correlation, autocorrelation between those particular observed values and as well as the previous sets of values. So usually, if you can plot this and if you can understand this particular partial autocorrelation, the differences, the errors between the current and the previous values, it keeps on decreasing over the period of time. It means you are properly preparing your model. That's what you can get a clear indication over here. So similarly, the autocorrelation, the R value is almost 1. The autocorrelation 1 for all the different lags or the different periods of time. That is the 20 lags which you have been considered here. Most likely you can go for the more number of lags if your software is supporting for that. And also you can see that every time series observation also consists of the seasonal values plus the trend values and the errors of the residues. So the errors are very much minimized, and you can see there is a graph which is coming from this particular set of values. So once you do this one, you can see this summary of those particular summary of those time series values. The p-value, Pearson coefficient, the Pearson p-value is basically the Pearson coefficient value is almost 1, which is a metric which will give you the indication that the time series, the model which you prepared and the model which you prepared and you are trying to do some kind of forecasting is coming correctly here. So once you see that kind of statistics, which will give you an indication that the model is getting prepared properly. So then you can simply plot the graphs, and of course you can run this particular forecast. You can see the corresponding set of statements. So let me just, I will run this one forecasting. At the end of the session, I will come back to this. Once the time permits, we can run this particular set of programs. So this is the basic time series 1. So now let me move on to what is machine learning. So basically, machine learning is in quick terms, basically it is a study of algorithms that improve with experience. So your algorithms which are running on your machine will improve the learning experience of the machine. So your algorithms or your models or your methods makes the machine to improve and act according to your inputs, the new inputs which are coming to your machine. So basically, your machine learning can have 3 different types of techniques to start with. So supervised learnings, unsupervised learnings, and reinforcement learning. So these particular things, I think you might have studied or you might have come across several times. So I don't want to spend much time on this particular aspect, what is supervised learning and unsupervised learning. But in a quick nutshell, please remember supervised learning, basically what are the observations that you are getting collected, what are the data that is being collected, the data is going to have certain kind of annotated value or a label value is going to be there. That will help to make the machine understand what that particular data is about. So here some kind of supervision, that's what the data annotation is, the supervisor here, which is giving you some kind of information about the data. So usually the input X, if you are giving to the machine, then what is that input X corresponds to and what is its target value is Y. So that corresponding value Y is been labeled. So you get the what that particular X corresponds to depending on the data that is been annotated by the machine that gives the correct value. So here, whereas in unsupervised learning, basically unsupervised learning is basically one kind of techniques where you have certain kind of classification, your clustering techniques. So where you group the data. Hello, yes, please. Hello. Okay. So here, these are some of the basic machine learning techniques that we use it. And of course, the same strategy when you are applying the time series techniques onto this machine learning workflow also do exist here. So the time series, basically whatever the time series analysis which we are doing, we collect the data and we do some kind of analytics. Once you do this time series analysis on the data collected, you try to give as an input to your machine learning models. So it is like some kind of sub-process for your machine learning workflow also. So that the machine learning makes a better predictions, and which can also be used. So most likely, most of the people do this machine learning. Of course, they do the machine learning process independently, irrespective of the time series intricacies or the internal details of modeling the time series values. So, but if you can combine this with the time series analysis outputs with your machine learning strategies, obviously the model becomes very more robust and very efficient. So that's what this particular idea is about, combining this machine learning with time series. So most of the techniques like which you see it here, which are coming in the last 5 to 6 years. So last 2017 to till today, if you see here carefully, if you see this orange colored dotted line is what your time series, the fresh, which is has come almost a very long way in the sense that in 2016, 2015, 16, it has come this particular method. And whereas if you see the CATS method, that's what I was trying to make you to understand. This CATS method, which is coming only in this particular year. Basically, this CATS method was proposed by Facebook Research. So to do the some kind of time series analysis on those Facebook data, this Facebook Research team has come out with this CATS method. Similarly, of course, this CATS is in this particular year only. And we have this gray kite. It is now the latest thing called as a silver kite. So this gray kite is basically again the brainchild of LinkedIn. And of course, this is also called as silver kite. Silver kite embeds or involves the gray kite method. What is this and how do you use? Just I'll give you a very brief information, just kind of. So, and gray kite is which is basically given by the LinkedIn, and this is also has been given in just last 2020 and 2021 only. And if you see, there are other methods are also there, but most likely this gray kites and these cats have not beaten this SK time. Still, there is a lot of things are happening there. I'll get back to you once I discuss with some small examples. Then I'll get back to you. So let us see how you can make your machine learning algorithms with the time series. Let me just take one example. We have a machine learning algorithm called as K nearest neighbors. And of course, this K nearest neighbors technique, we are applying with something called as dynamic time wrapping. So what is this K nearest neighbor? Basically, if you see, we have certain data points. If you see on the right side of the diagram, there are two different types of data points. So one is the square data points, another is your triangle data points. Now, if you see the relation among these data points, if you might have plotted a graph, you will get a complete idea. You have a new input or an unknown value on unknown. So now we want to find out this particular data point is more likely, or which is very nearest to which particular data point class. In other terms, the triangle class, or it is a square class. So in order to judge or in order to classify which is the nearest data point to this, of course, we use some distance metrics or distance mechanisms in the machine learning, as well as, of course, in the time series also, we use some distance learning techniques. Minimum distance finding techniques, starting with Euclidean distance, of course. So here, the actual problem for this K nearest analysis, K indicates a value which is very much nearer to this. It can be, if it is 1, obviously, what is the nearest neighbor? At least one neighbor which is nearest to the unknown data point here. So in other terms, given a new data point indicated by a circle, we find the closest known data points to it. So in this example, we find that the new point is similar to the triangle. So this point is very much nearer to this, nearest to the triangle. So we might assume that this new point is of the class triangle as well. So that's what we need to make an understanding. But how do you do this one? Yes, that because the distance mechanism, the distance is the thing that will help you to find out this point is nearest to which particular class of data values. So the distance mechanism is one such technique called with a dynamic. So here with neighbors k and the number of to base your output on, that's what hyperparameter when you are training. So this how many number of neighbors this particular. So ideally, if k is equal to 1, suitable class that you the output you are going to get, but it is very in an ideal situation. Please remember it. So the integration function, for example, the average or the most frequent value that you use to get into this, and the distance function to use the rest additional things that information you can get it from this. So what is a dynamic times useful to so usually algorithms for measuring similarity between two temporal sequences which may vary in speed. So here, if you see there is a red color line on the bottom of the figure, you can see there is a red color line and there is a blue color line here. But please remember, if there is red color line can be considered as one time series or a set of values or a set of data points with respect to units of time. Similarly, blue color line also indicates a certain set of data points with respect to units of time here. And more likely, if these two set of points are two temporal sequences, basically sequence, if they are not in other terms, if they are not the values, region of the blue color values it all. So from this particularly temporal sequences which are of different is going to be useful. Then now the distance. So give you some kind of distance between those to nature or the same speed or with the same other direction. So X1 series you can see here as long as your point Y series are matching, you can apply the equation. But sometimes because the values which are coming from another sequence is more or less, to compare with the existing Euclidean distance is not for you to find out what classify value. One dynamic time wrapping match light, so that make sure that the values are going to be obtained with this certain set of values. So here dynamic time wrapping with the k is when we come the explanation. Let us see what that is what is linked in, which is so this algorithm is 2020 title of primary author. So you can see this is basically a machine. So what is this this particular thing has come into picture is the additional time series usually will have. I am coming back to this value. Time series, the traditional, the old. So usually you have certain observations and from the get the corresponding So times is called trend and some kind of residues between the current and the is the current value and so these are the this time series in the techniques. So you will have certain these three aspects are only the things which is time. But today's data is data aspect. There's some employee organization also looking days in our days if you want to find out aspect of holiday or if you see that to correctly because people are which in we cannot easily answer for that. So so LinkedIn has added more of trends and seasonalities. So the silver kite different types of season, committed events, holidays, extra times more. It is used for both short long term means the number of days. What of things required? Adding more fact LinkedIn days. They can use the LinkedIn also in COVID data. How many number of cases will be there if you are applying model. So that's what I prepared some programs for you. So we will try to run those programs. Series is modeled as an additive the change points, holiday and effects, events. These machine learning algorithms have not taken care or not with this event effect time series modeling. And moreover, Silverkite also constructs indicator variables for our holidays because holidays can different countries will cannot customization events, seasonality, holiday, Silverkites, not only these particular internal factors which are influencing the observations of the data, which also includes that is calculated average value obtained here. It has got some feature. It comes execution for robust regulations can see get a better. So LinkedIn benchmarks of several data sets. Silverkite outperforms both AutoRima, that is the auto-regressive integrated moving average, that is the oldest and the traditional technique, and the profit. This profit is basically the Facebook profit. Now the advanced version of the profit is nothing but the CATS, KATS CATS package. So this what the claim is. Silverkite is better functioning than the existing. This was how do we use this Silverkite? We will and we'll also look into another, call it as XG boost. XG and boosting. Was published in 2006. Award also many problems and solutions. They have won those. So this is highly scalable number of machine learning algorithms and improve your into the current set of variables. So this is to regressions. Boost can be used for train based on the past and as well as so the variable on this which can apply it on. So let me just go with the previous programs and whatever we discussed, just the XG boost and the CATS, and open the new labs. Upload these programs from my problems. Before this session, I have generated. So let me, yeah. Let me go. This keyword. So this yeah. Let me K nearest neighbor technique. We try to use the machine is data set basically the sensor readings of the road XYZ based on those data, whether it's trying correctly or it's in the top. So, so for which set of this the robot has given in the value. Change those set of values, we will see of data values are. Yes, yeah, I'll just pause at this moment. Yeah, you can just put forward it. Yeah, Bhuvaneshwari Rath. You can put forward. Okay. So the time series fresh, which is already in 2000. In earlier they're not working this time puts and runs for you. Three step. Okay. One more package time series to just install it. Have your Anaconda, which is installed. If you have internet connection, then it's collab. Just using the data frame. So I'm trying to load this robot execution phase as fresh examples. Building. So Now I got it. Okay. So you can see this is a robot value, which is gives you the different set of readings. The prediction values are true or false. So that is why here the robot, it is the data has been loaded here, and this Y is the predicted, and the time series values which have been in the DF underscore TS, the data frame consisting of that. Let me just show you this data frame also. So this is the data frame. It gives you the X, Y, Z, and this is the force and the torque set of values for different set of observations. The robots is there, and of course you can see the data set also on the UCI library. So you have this many number of instances, the number of instances here, and now from this we are trying to extract the features from this data set values. So here the features, and you are trying to select those features. So here extracting the features from this data frame with the column ID and the time, and that particular data frame is being put on the array extracted features. Similarly, the selected features, what are the features that you are selecting is on the target value, the Y. So both we are now, I'm just given the original values into this set of values. Now I am trying to perform the transformations. So please remember the transformations, the feature extractions are happening here. Each row, each column values with respect to the time slots that the values are getting extracted here. So the columns include the time and the 6 time series, the XYZ of torque and XYZ of the force, with signals from different sensors, FX, FY, FZ like that, and the target value is being collected. So this is basically robotic execution failures. That's what it has taken time now. So failures from this UCI machine learning repository. Then once this columns values are extracted, you can see the features which have been selected from these columns. You can also run this set of values. So the feature extractions are also been done here. So if you see this auto correlations, feature correlation for the lag 8, 9 has been 0.98 is been set for this. For feature extractions, it is automatically running here, the time series container. So you are giving this entire data frame with the features and the selected values together. You are giving this model to this particular training. And if you can see this, now once you run this one, now let us plot the k nearest neighbors. So here the different metrics can be applied on the k nearest neighbor, dynamic time wrapping, DTW. That's what the technique. You can as well apply soft DTWs or CTWs, constant values also you can apply. So and you specify these particular grid values and try to you are trying to display the k nearest neighbor. That's what KNN technique. That's what you are applying the k nearest neighbors of the time series classifier. So once you run this set of statements, after you run here, let us see the y values, the features, the fit method. The model message is fitted with these features filtered from this set of values and which are mapping to this y are going to be displayed here. And that particular thing you can just plot it on the graph. So just can you hold on? I'm running this model, k nearest neighbor model again on this data frame. So you can see at the bottom of the screen, the executing is taking 37, 38. It will take a little bit time in the k nearest neighbor method to run it on the prepared data model with the features extracted as well as with the selected column on the target values. So it is very simple actually. People do wonder or do worry about how to apply machine learning algorithms. Please remember, writing very simple set of lines of program and trying to understand the data is going to be that much very easy here as far as the offline data analysis is concerned. So only applying the algorithms, and you need to know what type of metrics and what type of constraints that you need to assign it, and try to she will understand the summary of the Just hold on, it is still. Once this KMM model has been prepared, now you can see there is a green color tick mark. It took almost 2 minutes time to prepare that model, and you can see the neighbors have been dynamic time wrapping defined here. This so now data and the policy. So you can see this k nearest mean 1, which is, of course, this one nearest neighbor a little bit farther from this for the robot. So like this, you can just apply these things, and let me just go through it small again. Let me load my. So as I mentioned, originally these package so we run the silver. There's updated very quick test pack. So the dependencies also care properly. So sometimes 1 second, I need to comment. Yeah, Greek IT is now installed. You can see the green right now. Have the matplotlib bonds visualizations of the data. And see now, may I know using here? Can anybody tell me? Hello. You?
Yes, sir.
Yeah. So the data set is
But
basically.
sometimes voice breaking.
Yeah. So So the data set world.org, you can see our latest COVID data. So here I'm just applying the silver kite, the latest model on this COVID data. Let us see here. Now I'm just collecting the data, and that has been, yeah. So now you can see the data is being collected onto this our local variables, and so you can see the locations of this. So it is a worldwide COVID data is available from this particular website. So you can see here our, yeah, you can see there is India. Yeah, you can see this India data is there here, but please make sure that most of the time India data is not full, means it is available here. But if you look for certain European countries, the data will be very accurate on this website. You can change this supporting Indian understanding. This head Afghanistan 2020 head part. The number of cases at that time is new methods. Of course, this what, or there's a missing values here. Please remember it. Some countries may not have. So obviously you need to impute them. You need to missing values have to be taken care of the previous pre-processing. Otherwise, your predictions. I am just setting. If you see, set the India once I run, now we can the data, the data, and now I'm applying running this. So here date basis. So the data frame is going to be the data frame. Now for the applying the forecast method on this green silver kite method. You are looking for the horizon 90 days forecast time. We are trying to give it. Horizon means basically looking for the number of days which you are looking for. So if you see on the bottom of the screen, the program is getting executed. So the forecasting model is getting prepared, and the coverage is 95% confidence level on the getting the forecasted. So 5% is been. If you see the normal distribution curve, you know what is a 95% confidence level, and the 5% deviations will be there for us. So now, once this is completed, once the forecaster has prepared the model with the silver kite, just hold on, let us see the projections. Projections, I mean, this is the forecastings of these particular values. So the free folds, cross people do apply from the 4 kind of folds they have been considered in this particular. So people, the internal processor, the internal algorithm, they should be able to apply the method and configurations. How much confidence and what is the data that as the time columns at the date value columns which you want to look for new cases projection you want to do it, and the frequency day-wise so once you parameters silver kite So there are how many folds from the entire data sets and how the data has to be. It's completed now. Testing here. This is this value is the forecast is not accurate. We can see the forecast for training and it was just, we apply this silver cat. So silver data is not working properly. So that's why it is not understanding. That is the forecasted data. What is the lower maximum of this forecast here? I'll check. We will get back. Why? Because you just hold on. Values you can see here. The training correlation itself is 68%. So the mean square errors are also very high and they would be high. Prediction is not coming. It gives you the clear indication. See from the graph also the Indian collected from that particular website information. So that's what the problem with because you can see here. I can see here clearly. So when you have the null purpose, it has to be here. This thing is coming here. Imputation is not done. This prediction is also not correct here. So you can see that is today at 8/19 is tomorrow. At least it is forecasting 50,000. And of course, it may come to very near it, but actually that forecast is also wrong. Thing is not done properly here. So here, for this is similar type. The other machine learning, the other technique that we get XG boost algorithm. Let me open. So these are all boost. There's extreme gain. Run this. It is been in of course preparing with matplotlibs and importing the Panda. Same website, of course, from the Express. Remember this. So location is again in for the Indian data. Now we are trying to, now we are trying to transform, apply the transform function. So we are trying to now do the pre-processing here. So this will be giving a better result than the previous one. So in this we are applying the column transformers. So the date, month, we are going to use this and apply those transformers in the pipeline stage so that it will do very quickly. So now once you apply the transformer, after that you collect the features. The features have been collected here onto this date column values. Then you look for this prediction for the 1 day or 2 days, or for the new cases on this transformed values. For 1 day, you just prepared it and apply the regression, XGB regressor. So it is applied onto this transformed values. And now let us look for the 90 days prediction, maximum origin from the data frame, from the transformed data values. And let us do for the forecasting. Now, if you see here, once the data has been transformed, it is means the null values are taken corrected and taken care. Basically, now you can see here you can see here the basically the forecast and the actual values. So of course in the May it was increased. Now the forecast is on the blue color line. So at least now you can see forecast which is in here. Please remember the XG a better prediction here, almost range at least, which is not at least the forecast and the actual are in. So that's what the XG boost. This is what every month cases can be there. That's what we have. So the metric error, and you can see that is almost better than the previous. But you can change the values and run it. Yes, it will definitely work. Just save it. Let me open the cats. Another one. Let me check whether it is going to run or not. I'm not sure. Let me just try. So cats is a time model which you can easily list. The previous session is not. Sessions, this is the problem with this. We need to turn. Okay, try this. It's a little bit taking time here, so I'll come back to this and let us see here. So with this time series, we can also. This is one case study during my part of my PhD study. I have published this particular work. So you can see the forecasting the behavior of an elderly using wireless sensor data in a smart home. So basically, this work is nothing but collecting the data from various object usages in a home. So you collect the object usage. Objects means the real world objects like your water. You have your room heaters, toasters, microwaves, chairs, bed, televisions. So basically, you have electrical and non-electrical appliances which are regularly used by the inhabitant in the home. So you try to put some sensing systems connected to this object switch. You can see some black boxes over here, which are connected to these devices, which whenever this particular object is in use, so we collect the data. So there are these sensing systems are indigenously developed at our lab. Of course, I'm also involved in this particular work. And we have force sensors, we have electrical sensors, we have on-off sensors, and of course the different sensors which we have used it and prepared our own sensing systems. So sensors are different, sensing systems are different. So we design and develop the sensing systems with the help of the existing off-the-shelf available sensors, and we connected those to the system objects usage, and we collect the data here. So there is a coordinator, a ZigBee coordinator, which collects the data of those sensors which have been sent here. So that is, we collect the data. Of course, this is a wireless communication system that is established over here. That's what it's all talking about. And once we collect the data, we try to assess whether the person is doing their regular activities of daily living, whether they are regular or irregular. So we do apply different time series techniques. So I'm just trying to make you to understand one of the time series technique which we applied here for forecasting it, as well as finding the trend on the usage of those objects. So along with this technique, we are all we have included the other probabilistic and the sensor activity pattern matching, so that it can suffix those methods and give you more accurate answers in not generating the false alarms. So here, those are the other techniques which have been described here. I will not go through that very, but briefly let me tell you. So here the trend which has been found out from the observation values. So we have exponential smoothing techniques. So this is these exponential smoothing techniques were used to apply it easily on the seasonal decomposition of the time series data. So this forecasted value is depending on the local trend, as well as local trend means the seasonal trend. The season is nothing but the weekly. So the weekly here, the season is S is equal to 7 days. 7 days is considered as 1 week, and it is equal to 1 season here. So the week wise, how the person is behaving every week, that's what we are looking into that in that particular granularity. And also that is what the local trend within that week, how he is behaving. And within the 48 days, so basically a time series, basically the benchmark to collect the time series set of data to get a forecasted value correctly in the literature, it is given that at least minimum at least 48 days or at least 52 weeks you need to collect the data, so that you can better forecasting value. So we have the local trend as well as the trend which is for that particular past data of that 48 days or the 52 days, you can take it, and the seasonal trends. So with this decomposition of these three set of values, we were able to find out and forecast that particular value. Of course, the data forecasting is not very accurate. So we were able to find out the trend values, and we were able to find out the actual durations were collected. Those are the temporal aspects. Obviously, whenever data is being connected with the units of time, you apply the time series analysis to do that. And of course, we were able to get the normal distribution curve also for that collected data for most of the data, as you can see it. So because the daily routine of that inhabitant is a cyclic process, it's not that different. So we were able to collect those data, and for different object usages, we able to project their observations as well as forecast that particular set of values. And if you see those, we were able to get it forecasted within certain durations correctly, but most of the times there was false alarms also. So here you can see these red color lines which are not accurate for our, which is very irregular, which is not matching. So basically there are other internal factors for this which are not matching to this most of the time, of course. So that is what you can see as a case study. We were, of course, this work is done almost 10 years back. Is almost in 2012 this work has been carried out. But at that time, these were the classical time series algorithms. But later, nowadays, you can see we have the more seasonal understandings of the observations data, as well as you can see the internal granularity on the time series observations more effectively. Like that only the silver kite and the cats, these particular set of programs have come. So if you can explore this more on your set of observation data, then definitely you'll be most benefited to get some kind of projections here. So let me just, I will not take much time. Let me just conclude here. So we just seen the K nearest neighbor, the silver kite, and the XGBoost algorithms. Let me just say one word here for you. Time series forecasting is an important area in this machine learning. On a positive note, this gives us an additional information that can be used when building your machine learning model. Please remember, time series analysis will always give you the good insights of the data, so that your machine can understand very well and do better predictions in the near futures. So this not only the input features contain useful information, but also changes in input or output over the period of time. So the time series forecasting will be very much vital for you to make a good understanding of the data. And until unless you don't understand the data properly, you cannot build a good machine learning model, and of course your machine cannot project it properly. Yeah. Any question answers, please do put forward. Welcome you to put forward some questions. Thank you for patiently listening to my session here.
Thank you very much, sir. It is quite enough knowledge for the researchers regarding the data analysis through the machine learning, and also using the data series. So a lot of things has been discussed in this tutorial classes, and particularly it is highly encourageable to the new researcher to learn about this the concept through these practical sessions. It is a hands-on session which is a more novelty used in these sessions. Okay, have you any questions, please? Okay, sir. I have some questions regarding this time series analysis. In our group, two people are working under me. That is using this time series analysis for the text data. But another group of the people are working on this image processing. So how come it will apply for the image processing? Means image processing means not exactly direct image. It is coming from this different signal through the waveforms. See,
Data is coming in what form, sir?
In the image format. Like your heartbeat, sir. Heartbeat is
Okay. So you are collecting the something
heartbeat,
like heartbeats and
heartbeat and EEG, sir.
EEGs and ECGs. Yes.
Yes.
Yes, sir. Basically, yes. Most likely, if your machine or the machine that is collecting and giving the data properly, you can easily write this model and run it on your wearable device. Suppose usually your heart devices or your ECGs or EEGs or your skin temperatures, they have been put onto your wearable device. Wearable means a person is going to wear. So it will be very small size. And of course, you need to develop the system, your processing system, which includes your microcontroller or whatever it may be. Some processing element should be there. So of course, nowadays, if you see Fitsbees and other things which are coming in less sizes, and of course the cost is more, but you can improve it further. Now, how to apply the time series? Yes, if you have the memory capability to store the data, set of mostly in your wearable devices, you'll also have the memory unit to store the data. So once you store the data, that is basically you do some kind of online learning. So online learning in the sense that you try to summarize the data. You need not keep the very long data, the past data. You just give the summary data there. So once you collect the data, a few amount of data is being collected. Few means again, at least it needs something like 48 days of data to get more accurate data in the sense.
Yeah.
So if you are able to store that 48 days of data on that particular wearable device, and you run the algorithm and you get the summary. And for every 48 days, as a cyclic process, you can improve that particular model or the machine learning model on the wearable device itself. So that at least you can try whenever there is some kind of something going wrong with that person who is wearing that, which can easily trigger that, and it will not give a false alarms. So something the patient is going to have. The heartbeats are getting changed suddenly, or something skin temperature is getting changed suddenly. Usually, you can well in advance. You can say at least some 15 to 20 minutes before. You can easily get that particular indication. That's what you can prepare that system there as a variable device system.
Sir, nice suggestion, sir. Uh, Actually, some of the people are worried about this implementation of the different kind of the data, like structured data and non-structured data. Sir, is any difference kind of this application can be possible for the means using this your structure and unstructured data?
So basically, structured and unstructured is all depends on what exactly we are collecting the data, sir. Here, see what parameters are we collecting it into our wearable device. See, sometimes the sensors, what we deploy it on our body, sometimes they may not give. That's what we need to do some kind of pre-processing. If you unless until data is not properly structured, your data processing and data analysis is going to be very complex, and it is going to be very difficult, and the predictions will come wrong. So it all depends on that's what parameters are we looking, what features are we looking here. So how do we collect the data on what features, and how do you extract the features? So once you depends on the features, you prepare your data as a structured data or a unstructured data. We only try to consider it to go for a structured or unstructured. But in practical situations, please remember you will get an unstructured data only. You will not get a continuous data from the sensors. It is vulnerable and it is bound to happen. And we don't think that ideally all sensors will give you accurate results all the time. Never, it never happens. Even your Apple, Fitbits, and other wearable devices, they have their system which has been fine-tuned. They usually take care of not giving the abnormal values for you most of the time. So the electronic devices, electronic sensing devices, it is bound to have abnormal values, and that may leads to your machine learning not more accurate. So it is an unstructured data only you will have it. So again, we have different techniques. How do we store that, and how do we process the unstructured data on the electronic devices, either in a particular format, in a flat file, or if you want to fill the flat file contents with other set of things. So it all depends on the constraint computing devices that are being kept for those systems. So how if you put more computable devices, then obviously you get a better system from the data perspective. But if you put cheaper and less robust system, then obviously your output is also going to be accordingly. So, but most likely the intelligence, the smartness comes. How do we design and develop a better electronic system with a data analysis system? So the combination of that will give a proper output.
Yes, sir. Yes, sir. Thank you, sir.
Yeah.
I request audience have any questions, please directly you can ask. Hello. Okay, sir. So once again, thanks to you, sir, for giving a time in the busy schedule. Also, you can keep in your mind for us to share a couple of hours. You can share your view for our audience. Thank you very much, sir. Thank you.
Yeah, thank you, sir. Thank you very much, sir. Thank you.